Hello everyone, welcome to the second day of MSTW 2022 AI Workshop. I'm Jiaxiang, your moderator for today, along with Jin Han as assistant moderator. Malaysian Students Technology Week is Malaysia's largest students-led technology conference, and we are back again this year as a 9-day fully virtual event filled with talks, workshops, and a hackathon to look forward to. As for the theme of MSTW 22 this year, we have chosen sustainability to highlight the rising demands from the increase of global population coming into direct conflict with the health of our planet. We aim to share with participants on the three pillars of sustainability, namely social, environmental, and economic. Balancing all three pillars ensures the protection of the environment while improving the quality of life. To complement the team, we got 4 sub-teams in our MSTW, namely data, AI, energy, and biotechnology. Multiple workshops and conferences are held around the sub-teams. And today will be the second day of our weekdays events that will have workshops and a panel discussions themed with artificial intelligence, AI. Back to the event, our workshop today is dedicated for you, our audience, to know more about the AI algorithms and implementation, specifically in the machine learning future and its insight. Our speaker today is Dr. Muhammad Al-Obaidi, a PhD holder from UKM who is currently working in YOL Elite as head of IT and marketing. At the same time, Dr. Obaidi is appointed to supervise PhD candidates by the International Islamic University Malaysia and master students by the Schools of Computer Science and Engineering in Taylor's University. Dr. Obaidi is also the founder of AI for Call, a digital education company that designed a well-created curriculum for students on coding, AI, and machine learning. With his 17 years experience working on big data science, machine learning, deep learning, and immersive technology, we believe that Dr. Obey will bring us a meaningful workshop today. So without any further ado, let's welcome Dr. Obaidi for the workshop today. Welcome, Doctor.
Hello, good morning. Hi, everyone. I'm so happy and excited to be here. Thanks for having me. I hope everyone doing very well. Okay, all right. So about our today workshop, we are going to talk about the machine learning, future and insights. And our presentation and our workshop is going to be about the artificial intelligence, machine learning, and deep learning. We are going to see what are the differences among them and what each one refer to. Many people understand these topics as like separated topics while they are related to each other. And then based on the techniques and based on the understanding of artificial intelligence, machine learning, and deep learning, we are going to talk about big data and how big data related to all of those terms. And then we are going to move to talk about the people who are working in this field, the big data and AI, ML, and DL, which are the data scientists. And we are going to know what normally data scientists do, and then the tool and the requirements for data scientists, or how to be a data scientist, especially if you want to be a data scientist in your field, and why do you have to be data scientist in your field. Okay, and then we are going to move into detail about the machine learning and deep learning and the types of machine learning and deep learning and some of the applications of AI. I call it AI because based on our understanding of those terms, then you will know why we say the applications of the AI. And then we are going to see the AI applications in our 1 day routine. And you see like how extensively we are using the applications of AI daily. Then as long as we are talking about those applications and how do we use the applications of the AI, then definitely we have to refer to the Industrial Revolution 4.0, which is the current Industrial Revolution. And then what is that about? Then moving forward, we are step by step moving to the Industrial Revolution 5.0. So we are going to understand also what is Industrial Revolution 5.0 about. Then by the end of this workshop, we are going to do the practical part, which we are going to build a predictive model and build a descriptive model based on two types of the machine learning. And that one will be about doing a lot of coding and a lot of steps we are going to follow together. Then everyone, by the end of this session, by the end of this workshop, you will be able to have something to be added to your portfolio. I will also share with you how to create a portfolio, how to start working on your portfolio for the sake of either finding a job in the future, or if you want to start your own things, like providing services based on those techniques, or you want to provide a consultancy or anything that related to the AI and big data. All right. Just a quick one about me. I have a bachelor in electronic and electrical engineering. I have a master in computer science. I was working on information hiding under security, and I have a PhD in artificial intelligence. I'm the founder of those two companies, the AIC for All, which is the artificial intelligence and coding for all. We started it as education company, digital education company, to provide the awareness and the understanding of AI and coding for preschool, primary school, secondary school, and adults. Then now we are moving, beside the company considered as education company, we are moving to provide also software, to provide services based on AI, and also to provide consultancy. Then I'm also the founder of the second company, which is the Innovative Eye. This one basically, I started it earlier in 2018, and that one was focusing on digital marketing and multimedia. And then now we are working on a new project, which is how to use the immersive technology, which is the technology in the 360 environment, with the AI techniques to build the best marketing campaign for the social media. It's quite a new field. It's quite a new project, but I believe this is going to be the future of the digital marketing. Then I'm also a certified trainer, so that's why I provide the training courses. I have trained almost 2,000 people here in Malaysia to be working in the field of the big data and data science. Either they started to work as data scientists, or they work as data analysts, or anything that related to the data science. Currently, I'm delivering those two training courses, which is the data science and analytics, and the other one is the applied artificial intelligence engineering. The first one, it is part of the AIC for all, which is the understanding of AI and coding for adults. And the second one is considered as a continuous course for the first one, mainly the artificial intelligence engineering, applied artificial intelligence engineering, mainly for the advanced, considered as advanced course, and we are focusing on the computer vision and the applications of deep learning. Currently, we believe deep learning is going to be on high demand in the future. Okay, all right. So to start our workshop, the differences or the understanding of the artificial intelligence, machine learning, and deep learning. When we talk about artificial intelligence, it means we are talking about something that started earlier in the 50s, or when the computer machine came to our life, came to be used in our offices, or even for our private usage. And the first application, or the first understanding about artificial intelligence, is the calculator. So artificial intelligence, it is about how to make the computer machine smart, or how to make the computer machine think like us. So how to ask the computer machine and to get the answer from the computer machine based on how we answer questions. And how to do so, normally we instruct the computer machine to answer our questions. So everything is like a predefined, pre-instructed. And how to instruct the computer machine, it is by communicating with the computer machine. And how we communicate with the computer machine, we communicate with the computer machine by using the computer programming language. And I think many of you are aware of the current programming language, like Python programming language. Later on, we are going to talk about Python, Java, C++, and many other computer programming language currently we use to communicate with the computer to make the computer think and answer questions like us. So this is the basic and the fundamental understanding of artificial intelligence. Then we moved to machine learning. Machine learning is considered as a field of artificial intelligence. So machine learning is under artificial intelligence. So now instead of everything to be coded, and instead of writing coding for every instruction, now we are using the statistical algorithms, which are the algorithms under machine learning. Those algorithms are learning from the huge amount of data, all right? And that learning going to be applied on the new coming data, or going to be automate things for us. So we are still doing coding, but it is much lesser coding than before, because now we have a huge amount of data. So these algorithms are learning from the data for the sake of predicting things for us, or to build something we call it a descriptive model, which is to group the data into groups based on the similarity of the features of that data. Okay, so this is the machine learning. And then talking about deep learning is considered as a subfield of the machine learning. So deep learning is considered as also under artificial intelligence, and it is a subfield of machine learning. First of all, why it is a subfield of machine learning, or we call it a subfield of machine learning, because one of the machine learning algorithms, which is the artificial neural network, ANN, or sometimes they call it a neural network, it was developed and it becomes more complex to work on the huge amount of data that currently we have. It is one algorithm of the machine learning. So that's why we call it a subfield of the machine learning. And the advantages of the deep learning, it works on the huge amount of data, and it was influenced or inspired by the structure of the human brain, by the structure or the architecture of the neuron in our brain, how the neuron works. The artificial neural network now, it works based on that, and it is considered as the most promising algorithm to provide high accuracy rate when you are going to build a model, either a descriptive model or it is a predictive model. But the only thing about deep learning, you need a huge amount of data. And as long as now we are in the era of we are in the era of the big data, right? But we are moving to have the data increase exponentially, especially now we are moving to use 5G. We are still not completely everywhere using the 5G. Now we are moving to use the 5G. So we believe the amount of data is going to exponentially increase. So that's why we need algorithms to handle that huge amount of data. Okay, so these are the main differences, or the main understanding of artificial intelligence, machine learning, and then deep learning. So just now you heard about big data. I mentioned something related to big data. So what is the big data? When we talk about big data, normally, if you didn't read about big data, or if this is the first time you heard about big data, you may think big data, it is about the amount of data. You will think big data, maybe it is 2 terabytes of videos, or big data, 1 million images. Big data, or 1,000 pages of Microsoft Word is considered as a big data. Big data is not about the amount of the data. Big data, it is considered. Before that, if you look into the books that related to big data, or if you look at any available courses or blogs or vlogs, you will see it is quite difficult to have a definite definition of the big data. But when we talk about big data is considered as the data that generated by machines, which are the machines that we use, or the machines that we have in the offices, or in the universities, or in the government offices. So those are generating data, or us as individuals, we are generating data daily. So we need a way to archive the data, sort the data, clean the data, and start to analyze the data to get insights from the data. And those insights going to be help us to create a value from the data. And that value could be money. You can make money from that data, those insights from the data, or you can improve services, you can improve the infrastructure of the countries, you can build a better healthcare system, you can build a better education system, and so on. Okay, so what is the meaning of the big data, or what is, like, if you want to understand the big data or you want to define big data? So many books and many related courses, people into big data, they understand big data as those V's. We say when we have these V's, we are going to say that data is considered as a big data. Like by IBM, they say big data is considered as the data that have those 5 V's. Other education provider consider big data are the data that comes with these 6 V's. Sometimes they consider it as the 10 V's or 4 V's. So what are those V's of the big data? And after those V's of the big data, I will share with you my own understanding or observation of the meaning for the big data. So let's talk about the one that's provided by IBM. So this is related to the professional course for data scientists, advanced data scientists by IBM. They consider big data the data that comes with those 5 V's, which are velocity, volume, variety, veracity, and value. So what is the velocity? Velocity, it is about the speed that data accumulated. Let's take an example, which is ourself. If you look at our mobile device, every day when we wake up, then you will see you have received, like, I would say like quite a lot of data, which are coming from maybe the social media, either the Facebook and Instagram, WhatsApp, or whatever. You are receiving data, and those data could be considered as video, could be considered as images, could be considered as PDFs, Microsoft Word, any other data. You are receiving emails, you are receiving other data, maybe related to your work or maybe related to your hobby. If I ask you now, can you remember what did you receive like yesterday? It's quite difficult to remember, right? Even yesterday. What about if I ask you, like, what did you receive last week, or what was the data that you got from specific party or specific friend like last week? Is it quite difficult? So quite difficult to remember. So you can see it's like the data accumulated in a speedy time. So this is one of the facts that make that data as a big data. The other fact is the volume. The volume is the scale of the data or the size of the data. If we talk about ourselves, we continue with the same example, which is the example that related to us. It's like if you compare yourself to 10 years ago, when you used to buy a laptop or when you used to buy a device, I think maximum the storage was for the device maybe 16 GB or 32 GB. It was maximum. But currently, I don't think any one of us will buy a device with 16 GB, because now we are demanding for more, for a bigger storage. Now some of the mobile devices, they come with the 1 terabyte, which is 1024 GB. Why? Because we are archiving a huge amount of data. We are like, and because of the scalability of the storages, and those storages become more affordable. So that's why we are demanding for a bigger storage, and we are archiving more data on those storages. So this is the second fact of the data, of that data to be a big data. The third one is the variety. Variety, it is about the formats of the data. Continue with the same example, which is ourselves. If we look at our device, or we look at our personal machine, like a laptop or desktop, you will see we have PDFs file, we have Microsoft Word file, we have videos, and even the videos, they come in different formats. We have images, they come also in different formats. For me personally, I do some graphics and movie montage. I have like a lot of formats that related to that media. Maybe for you, if you are like into architecture, or you are civil engineer, or you are mechanical engineering, or whatever you do, finance, law, you have the data that related to your field, which come also in different format. So you can see the format of the data vary from one data to another. And one more thing, when we talk about the variety, we talk about the structured and unstructured data. The structured data, you may ask, what are the structured and unstructured data? The structured data, it is considered as the data that comes into rows and columns, like the data that you can read it by the Excel sheet, or the data that we can read it by any programming language, like by Python programming language. That data is considered as structured data. So we can work on that data because we have the values. But most of the current data that we have consider as unstructured data, or consider, or we call it the messy data. 80% of the data that we have currently is considered as a messy data or unstructured data. So this is another fact to make the data that we have is considered as a big data. And then definitely we need to know how to structure the data, how to make that data into rows and columns. Then we can use those machine learning or deep learning algorithms and the computer programming language to work on the data. Then moving forward to the fourth fact that make the data big data is the veracity. When we talk about the veracity, it means the quality of the data. Again, with the same example, from time, which is ourself for the big data, you can see it's like from time to time, you will open your mobile device and you will start delete some of the data because you believe that data, you don't need it. So that data is not considered as a quality data that is not related. So that's why we are in the field of and moving forward, we are going to move from big data to a good data. Not all the data that we currently have is considered as a good data to be used to get insights and to use those insights to generate a value. Okay, and always the amount of the good data is considered as like a smaller chunk or smaller amount of the big data. All right, and then the last fact of the data of the big data, it is the value. Value, it is about when you have a data and that data can initiate or can create a value for you. And as I mentioned just now, value can be money or can be something related to improve the infrastructure of the country or to improve any system that is good for us. Okay, all right. So these are the facts of the big data. These are we call it the 5 V's of the big data based on the understanding of big data by IBM. I'm not going to say this is the best or this is the right one. Definitely, other books, they believe big data is only 3 of those V's. Other like training provider or courses, they believe big data comes with the 10 V's. I believe all of them are sharing the same understanding. All of them, they have the right to have that kind of understanding about the big data. But let me make it easy for you. Let me share with you my own understanding about the big data, and I believe you will agree with me. We moved from, currently, we are using computer programming language to handle the data. Currently, we are using machine learning algorithms to work on the data. Currently, we are using, and in the future, you will see, we are going to use deep learning algorithm to handle the huge amount of data. All right. A few years back, we were not using all of these algorithms to work on the data. We were only using the Excel sheet to handle our data. All right. We use the Excel sheet to get insights about the data. We use the Excel sheet to get some analysis and analytics about the data. We use Excel sheet to do a lot of statistical observation and measurement by using the Excel sheet. Currently, we cannot use the Excel sheet to handle the huge amount of data. The amount of data currently is beyond the ability of the Excel sheet. So that's why we are using computer programming language like Python or R programming language. And currently, the problem that we have with the current data cannot be handled by the Excel sheet. So that's why we moved to use machine learning and deep learning algorithm to handle to handle those problems. One more thing, the insights to generate the insights or to get the insights from the data that we have currently, we cannot have it by the Excel sheet. So that's why we use machine learning and deep learning algorithms. So at the end of the day, I would say it's like to understand big data in a simple way, it is the data that we cannot handle it by the Excel sheet. As long as we cannot handle the data by the Excel sheet, as long as we have to use Python or any programming language to handle the data, as long as we need to use machine learning algorithms and deep learning algorithm to work on the data, to build a descriptive model, to build a predictive model, to get insights from the data, then that data is considered as a big data. All right. Then moving forward, you may ask, so we talk about big data and the understanding of the big data. Then we talk about computer programming language, and we talk about algorithms and building predictive model, building descriptive model, and all of these things. So definitely we need people to work in this field. And this field in general, we call it the data science, all right, which is the field of working on the data, manipulating the data, processing the data, getting insights from the data, and those insights going to help us to finding the solution for the problems, to make recommendations, and to have a new findings, and those findings can improve the performance of that data, or let's say, like, for a company, when they have the data, they want to improve the profit, they want to improve the performance, they want maybe to reduce the cost of some of their costs, and so on. Okay, so that field is the data science, and people who are working in that field, the data science, we call them the data scientists. Again, if you talk about data scientists, or if you want to define data scientists, it's a quite vary from one book to another based on what I read recently for the last 5 years. So each one, they have a different understanding about the data scientist. But I believe data scientist, it is someone which is curious enough to get those insights from the huge amount of data that we have currently, or we can say it from the messy data. Just now I share with you, I said 80% of the current data that we have is considered as a messy data. So anyone who is curious enough, who is eager enough to get the insights from those messy data, can be a data scientist, or can call that person as a data scientist. So what normally data scientists do, in simple way, data scientists do either one of those three models. They build a predictive model or forecasting model. They build a descriptive model, which is the model that to group or cluster the data into groups or into clusters based on the similarity of the features of that data. All right. And then the other model, which is the most common currently, all of us use it, I'm sure, but we are not aware of it, which is the recommender model. Recommender model is based on the usage of those two models, predictive model and descriptive model, and to recommend things for us. I think all of you are aware of, or maybe use Netflix. All right. So Netflix normally they provide, or they recommend to you series and movies based on what do you like, or based on what is the current trend in your area, or in your neighborhood, or in your, like, related to the people that you follow and follow you. This is considered as, we call it the recommender system, or we call it the recommender model. YouTube, I think all of us have been to YouTube. You can see once you watch a video, then in a few minutes will be other videos that related to the video that you watched will be recommended to you. E-commerce sites, once you buy an item from any e-commerce site, you'll see a lot of other items will be recommended to you based on that item, or based on what is the current trend in your area, or in your country, or neighborhood. All right. So normally data scientists, they do these models. Then, as long as data scientists, they build or they work on these kind of models, so what are the requirements of being a data scientist? And I believe many of you are either students or about to finish your study. So I think this is the right time to start dive into this field, to start work on the data that generated from your field. And when we talk about data scientists, not only those people who are graduated as computer engineering, or graduated as information technology, or graduated from the faculty of computer science. No, everyone can be a data scientist. And why everyone can be a data scientist? Or I would say, why do we need data scientists in every field and every industry? Because every industry, every field, if you look at it now, they are generating data. So we need people to work on that data. So definitely we need data scientists to work in that field. Okay, and it was said there is no any better time than now to be a data scientist. Why? Because you are going to be successful. This is the fact of the life. You are going to be successful when you are going to be, no, I should say, you are going, it is like way easier to be successful and way easier to shine in your field when you are going to have less competitors, right? Currently, we need data scientists in every field. I'm sure no matter what is your field, I'm sure in your field, currently we don't have enough data scientists. So that's why we it was said that there is no any better time to be data scientist than now. So you are going to have less competitors in your field, then you are going to be successful in your field faster, easier, and you are going to shine in your field. All right. So what are the requirements to be data scientists? And what are the tools that normally data scientists use? Data scientists, they use all the algorithms that under AI, machine learning, and deep learning. Just now we mentioned about AI, and we said what is AI, we said what is machine learning. Again, machine learning is considered as a field of the artificial intelligence, and deep learning is considered as a subfield of the machine learning. Sorry, deep learning is considered as a subfield of the machine learning. And when you talk about machine learning and deep learning, it means the algorithms of the machine learning and deep learning. And those algorithms all based on statistics and math. So you may ask, or you may feel like statistics or math is not something that you like to do, or not something, or not those two subjects are not the subjects that you like. Like for the more than 2.5 year training people, many of them not into math or statistics. Many of them, they don't like those topics. Many of them also, they didn't study these subjects in their field, like those coming from medical, those coming from the law department. Definitely they didn't really emphasize on those two subjects. Then how to be data scientist? As long as you are going to use, or as long as you have to use all of those statistical algorithms, and all of those algorithms based on statistics and math. The good news is, currently we have a lot of tools, we have a lot of libraries, and all of those libraries and tools provide for us the functions, and those functions based on complex math, complex statistics, and complex coding. All right. So you are not going to require to do all the math and the statistics behind them. You just need to know how to use them. Like, for example, I think now all the devices, either if they are Android or iOS, they come with some app which are related to modify and touch up images. And those apps based on complicated codes, based on math, based on complicated image processing. All right. And you can see now those apps are very, very efficient and professional to do the touch up. And every one of us, we can touch up the images, and we can have those professional images. Do we have to know the coding of those apps? Do we have to know all of those complicated image processing and math for those apps? No, we just need to know how to use that app. So we need to know how to use that tool, which is related to machine learning and deep learning. We have the tools now. We have libraries. We call them the the algorithmic libraries. One of them, it is this one. I mentioned for you. I put the logos here for all of those current tools and libraries available for data scientists to be used. One of them, as long as we're talking about the algorithms of the machine learning and deep learning, it is we call it the scikit-learn. Scikit-learn is considered as one of the well-known algorithmic library developed by Google, and it is very common for anyone in the field of big data, data science, or data scientists when it comes to the machine learning algorithms. All the algorithms, you will find them in that library, and you can just call the algorithm by the name of the algorithm. You are not going to write the code of the algorithm from scratch. You can just call the algorithm, and you can use that algorithm to work on the data that you have. All right. So as long as talking about the algorithms and as long as we are talking about the libraries and all of those tools, then definitely we need to use a programming language to do all of these steps. Sorry. And the common programming language when it comes to the field of data science, or when it comes to someone wants to be data scientist, then we should talk about Python programming language or R programming language. If you ask me personally, if you are good in coding or if you are very fresh to coding, then Python programming language is going to be the best and the right choice for you to start learn and master and to be used in this field. First of all, Python programming language is considered as multi-purpose, object-oriented programming language. You can use it for data science, you can use it for mobile apps, you can use it to web development, you can use it to build the software. So it's considered as the most common programming language for data scientists. It's considered as the fourth programming language worldwide. It is easy to learn. It is specifically for those who are very fresh to computer programming language. All right. And it has like the wide libraries, very wide libraries and tools in the field of data scientists and in the field of data science for data scientists to use them working on the data. But when we talk about data science and data scientists, we always see our programming language also involved. If you buy a book that related to data science, or if you buy a book that related to machine learning or deep learning, you will see in that book Python programming language, and sometimes, especially the recent books, our programming language also been mentioned in those books. Why? When we talk about the data and the big data, we build those models, the one that I mentioned to you, which is a predictive model and descriptive model. So before that, we need to get insights from the data to build those models. Those insights, it means we do analysis and analytics on the data. Analysis or analytics that we do on the data is considered as a lot of statistics. Our programming language, it is very powerful and efficient for statistics. So that's why recently there's also a job title offered by companies worldwide, not only in Malaysia or in the UK, worldwide, to work not as data scientists, to work as data analysts. Normally, data analysts, they do a lot of statistics about the data. So I believe our programming language is considered as good language if you want to do statistics, if you want to do statistics on the data, or if you want to do analysis or analytics on the data. But it doesn't mean that Python is not, you cannot use Python to do those statistics. You still can use Python. Python is going to be considered as more than enough, even if you are advanced data scientists, more than enough for you to be used. But R, I believe when it comes to statistics, is going to be faster. But the thing is, or the difference between Python programming language and R programming language, if you are fresh to any computer programming language, then it is going to be a little bit difficult, or I would say it's difficult to learn R programming language, but it's going to be easy for you to learn Python programming language. And at the same time, if you are familiar with the Python programming language, or you mastered a Python programming language, then it's going to be easy for you to learn our programming language. Okay, so again, the best or the advice is to start with the Python programming language. You are going to save time, and you are going to learn in a very fast way about how to use those libraries and tools to work on the data. Okay, one more thing, the requirements or the tools, the requirements for data scientists. Data scientists, they do something we call data wrangling and EDA. EDA is exploratory data analysis. Data wrangling recently, because of the current demand to work on the data and to get insights from the data wrangling or data cleaning or data manipulation is considered also a job title offered by companies. So what is data wrangling about? Data wrangling, it is about how to clean up the data set, how to get the data set ready to be used to get insights from the data. So normally any data sets, when we have the data set is considered as not clean. So what does it mean, not clean? It means that data set, it has issues. And those issues can be, one of them is the missing values. Some of the cells and the data sets, we don't have any value in that cell. So we need to find a way to solve that issue. We need to find a way to replace the missing value in that data set. So this is what normally people and normally like data scientists or people like working in data wrangling do. They fix the issue of the missing value. They fix the issue of the data formatting. Sometimes the format of the data is not right. We need to put it in the right format. Sometimes we call it something we call it data standardization or data normalization. Data normalization, it is about how to convert the values of the data set from like big gap between the minimum value and the maximum value, to convert those values to be in between 0 to 1. And this is what we call it data normalizations. And when it comes to data normalizations, we have methods, we have tools also to do the data normalizations. You may ask, why do we need to convert the values to be in between 0 to 1? When it comes to computer machine, when it comes to any algorithm, and when it comes to work with the computer machine, it's all digital. Digital, it means binary. Binary, it means 0, 1. All right. So that's why, sorry, that's why we need to convert the values to be in between 0 to 1. It's going to be easier later on for the statistical algorithm to work on the data between 0 to 1. So this is one of the things that normally we do during the data wrangling, and what people do if they are working as data wrangling. Okay, and many other issues. One of them could be turning categorical columns to numerical columns. So what is that about? When we have a data set, we have columns, right? And those columns consider as the features of the data set. And sometimes in the books of the machine learning, those columns, they call them, either they call them features or they call them attributes. Some of the column are values, numbers. Could be negative values, could be positive values, could be normal numbers, could be decimal numbers, and that's what we call it floats and integers when it comes to computer programming language. But anyway, that column, as long as the column comes with numbers only, so we call it a numerical column, because this column is all about values. Other columns comes with the like let's say we have a data set, and the data set is about cars, and we have one of those column, it is the car make. So the car make will be like, you are going to have like Toyota, Mazda, Proton, BM, Mercedes, Porsche, Jaguar. So in that column, sorry, in that column we don't have any value. We don't have any number. So that column, all the data in the column consider as categorical data, categorical values, all names, all letters, characters, could be some like related to like country code or some other things, names or whatever. So that column is considered as a categorical column. So this is the difference between categorical column and numerical column. So when it comes to categorical columns, it is quite difficult later on for the algorithm to deal with the categorical columns. All right. So there are ways, and we always look for ways to convert categorical columns to be numerical columns. Why? Because statistical algorithms, they work with numbers. They prefer to work with numbers. It's easier for them to work with numbers. So one of the issues that we solve under data wrangling, it is to turn the categorical column to a numerical column. But it doesn't mean when we have a categorical column, there is no way to work with it. We still have some of the machine learning algorithms can work with the categorical columns. All right. So these are the main things that normally people during people into data wrangling or the stage of data wrangling, they do. Moving forward is the exploratory data analysis, which is the EDA. EDA, normally it is after data wrangling. Okay, EDA, it is about, or it is the first step to get insights from the data set. Okay, one of the insights, it is about to find the correlation between the features or between the attributes. Features and attributes again, consider as the columns of the data set. So to find those insights, or to find how correlated one column to another column, or one feature to another feature, or one attribute to another attribute, this is what we do normally during the exploratory data analysis, and we have tools to find the correlation. You may ask, what is correlation? Correlation, it is about when we have values into two features, you will see if they are correlated, so they are like continuously increase or continuously decrease, or like one value in a column continuously increase while another value continuously decrease. So this one, we call it, they are correlated in terms of the values. All right, so this is the EDA. By the way, sorry, when we talk about data wrangling and exploratory data analysis, both of them under the job title or under the field of data analyst. All right, or under the data preparation when we talk about the data science methodology. Later on, I will just go quick on the what is the data science methodology and what are those steps that we follow to build a predictive model. All right. Another thing for the data scientists, they need to master also data visualization. When you talk about data visualization, it means how to visualize the data, or how to visualize the new findings, or how to visualize the problems that you solve, or how to visualize the method that you use to work on the data and to solve the problem of the data, or to get the new findings and how to improve things. All right. Normally, when people, they hire you as data scientists, either you are going to work for them full-time, or you are going to work for them as a service provider. They are not into this field. They are not aware of all of these techniques. They don't even know what is machine learning or big data about. They hire you to solve their problem. So to make it easy for them to understand the way that you solve the problem, or the way that you are going to improve things, you need to use visualization. Visualization, it means you need to use all the graphics, the flow charts. First of all, now we are this generation living in the era of everything to be understood by graphics. It's not only for the data science or data scientists. We understand and we learn things when there are graphics. If there's an image, we will go and read. If there's a video, we will listen. If there's only text, we may feel like bored, or you may feel this one is like it's going to be not recommended to read. All right, so that's why you need to master some skills about data visualization. I think some of you, or maybe many of you, heard about Power BI, which is for data visualization, and this one is developed by Microsoft, and it is for those who are not into coding. They don't want to use coding. They want to use like a software with the blocks, like you are using Key or PowerPoint. All right, so it's all blocks, all options. Then you do the presentation or whatever. So Power BI, it is also for data visualization, all blocks, all options. Then you just need to work on that. You just use it to work on the data, to visualize the data. And I think Power BI recently, they do also some data analysis, simple data analysis. Another tool is also currently common for data visualization is Tableau. So Tableau is considered as another tool to do data visualization. And those two softwares, for those who are not into coding, or they don't want to use coding to visualize data and to visualize the insights about the data. If you ask me personally, or you may ask, so why should I learn data visualization with the coding program, with the programming, computer programming language? I use codes to visualize data as long as I have those softwares. And those softwares, if you ask me, they are good, and they provide good results. You have both choices. The choice is yours, but just keep in your mind, when you use the software, you are going to be limited to the options that offered by the software. But when you are going to learn and use data visualization by coding, there is no limitation. The limitation is your skills. The more skills you have, the better visualization you are going to make, the better visualization you are going to work on. So with the softwares, there's a limitation. With the coding, there is no limitation. All right. And definitely, if you ask me personally, I come from someone who likes to use coding, then coding will be more fun to use for the visualization. All right. Other thing that you need to master, it is the SQL, or sometimes they call it SQL. And this one is a very simple commands or syntax statements language to deal with the data sets. I'm not going to consider it as a programming language. It is very simple. It is only the way to deal with the data sets, with the databases. Databases, it means a place that we have a lot of data sets, we have a lot of tables, and those tables are related to other tables, all right? And why do we have them? Because we want to store the data on the cloud. Currently, we are not storing the data because of the huge amount of the data. We are not storing the data in our personal device or our personal or portable storages. We are having the data, and especially for companies, they have the data on the cloud. So we use SQL to deal with the data on the cloud, all right? To access the data on the cloud, to update, to delete, to change data on the cloud. And then we use Python to do the analysis and analytics, and building those models can be also on the cloud. All right, so these are the main tools and requirements that you need to master, that you need to learn to be data scientist in your field. Then later on, definitely you need to market yourself. If you are looking for a job to work as data scientist, you need to market yourself. If you are looking to provide service as data scientist, then you need to market yourself. If you want to do consultancy, then you need to market yourself. And I think the best place to be to market yourself, to find job, and to be found also, it is LinkedIn and GitHub. LinkedIn is considered as a professional social media platform for those who are in this field. Definitely, LinkedIn is not only about data science and data scientists. LinkedIn it's for all professions. But I believe LinkedIn is the best place to be if you want to be in this field. And please try to use it professionally. LinkedIn is not for entertainment. I can see like recently some people, like they take a selfie and they post on LinkedIn. They take a photo for the food and then they post it on LinkedIn, which is not related at all, or it's like misuse of LinkedIn. You have other social media platforms, you can use it for entertainment, but LinkedIn is for professional use. And LinkedIn also is good if you can learn how to use it. Then you are going to increase the rank of your profile, and you are going to get found faster and easier. And people, they will come to you. People, they will offer you to collaborate with them. People, they will offer you a job. And even if you want to apply for a job, you can apply for a job easily by LinkedIn. LinkedIn also can be considered as your e-resume, considered as your electronic resume. Normally, I don't like to show off, and I don't advise people to show off, definitely. But when it comes to LinkedIn, it's good to show off your knowledge. It's good to show off your understanding about data science. It's good to show off the projects or the coding or the data visualization or whatever you have done so far with the on your projects on LinkedIn. So to show your knowledge and to show people like what do you know, so people, they will ask you to join them or to work with them. And if you are going to build any predictive model, any descriptive model, and today we are going to build two models, all right? And those models can be used in your portfolio. You may ask, what is the portfolio? Portfolio, it is a place to show the project that you work on. Why do you need a portfolio, or why do you need a projects to work on? Okay, so as long as you have projects, as long as you have tried to work on data and on the internet, there are thousands or maybe million of data sets available now for training. All right, for those who are a fresh data scientist, to work on the data, to feel the data, to build a predictive model, to build a descriptive model, to use the algorithms of the machine learning, to use the algorithms of the deep learning to work on the data. So you can build that project, you can get the result, you can justify the result, you can discuss the findings, you can show how did you solve the problem. Then that project, you can upload it to another social media platform called GitHub, which is this one. GitHub is considered as for those developers, which are professionals into coding, those who are data science and in the field of data science, those who are data analysts, data scientists. It is a good place to show off your knowledge, to show your projects. And even when I provide the training courses with my trainees, we work together on at least 6 to 8 projects. Then they can have it in their portfolio, so people, they can see what did you do. They can see your understanding about the algorithms. They can see your understanding about coding. They can see also like the steps that you follow to work on the data. So it is a way to show experience while you don't really have the experience yet. Okay, if you are a beginner into this field, if you are like this is the first time for you to work as data scientist, to show those portfolios. So this one is to provide you experience, to provide you like, okay, you know how to deal with the data, you work on the data, so now it is the time to work on the real data by that company. Okay, you may ask about the real data set. There's a website called Kaggle, all right, kaggle.com, and that website provide thousands of data sets, real world data sets. What does it mean, real world data set? Real world data set, it means a real data set. It's not a dummy data set or it was created. It's a real data set, but definitely there is no company or there is no provider or there is no any party or committee they were going to provide you their data, because data is considered as a privacy, right? But they will provide a sample of the data. All right, that sample is good enough for us as beginners data scientists to feel the data, to work on the data, to build a model based on the usage of the algorithms, either by machine learning or deep learning, and then to show our experience, then to get a job to work as data scientist, or at least to be a service provider as data scientist. Okay, all right. Another question you may ask, okay, what are, or maybe it's like, how long does it take to be a data scientist, or how long does it take to master those tools? If you ask me personally, not because I'm providing these courses or not because I have trained a lot of people so far, but if you are a very fresh to this topic, then it's going to take 3 to 6 months to master those tools. If, like, let's say if you are working or you are studying currently, then it's going to take for you maybe 9 months or maximum 1 year to master those tools and to secure a job as data scientist. And I will show you what is the demand to be data scientist, and even the salary wise of data scientists if you want to work as employee, and what is the future of the data scientist. I think it's worth it. I think it is a field that's very promising later on for your future, and the demand currently is high, and in the future is going to be even higher. All right, then we talk a lot about coding and machine learning algorithms and all of those algorithms, and data scientists, they need to master those algorithms. So what are the types of machine learning, or what are those algorithms under machine learning or under deep learning? When we talk about the types of the machine learning, then we should mention those 4 types. Mainly recently, the books or the courses related to the type of the machine learning, they focus on the supervised machine learning and unsupervised machine learning. But I'm going to share with you a little bit more to have like a good fundamentals after this workshop, good understanding, good fundamentals about the machine learning. When we talk about machine learning, we should talk about supervised machine learning, unsupervised machine learning, semi-supervised machine learning, and reinforcement learning. Supervised machine learning, it means, or the slogan of the supervised machine learning, train me. Supervised machine learning, we have the data, all right, and we know what is the data about. We know the description or the label of the data. And what is our main purpose under this type of the machine learning? We are going to build a model, and that model going to learn from the data. Okay, this is the data and this is the label. Okay, going to learn from the data and the label, and then that learning going to be applied on the new coming data which are not labeled. All right, so you are going to have a model, and that model learn from the data, learn the label of the data, and then the model will automatically label the unlabeled data based on the previous learning. And this is exactly what we call it a predictive model. All right, and why do we need a predictive model? Because now we have a huge amount of data. All right, we don't have time and we don't have enough people to label the data. So what about we use the computer machine to automatically label the data based on the pre-labeled data, or to label the new coming data based on the pre-labeled data. So this is the predictive model, and this is the supervised machine learning. And all the algorithms under the supervised machine learning consider as either for regression or classification. When we talk about regression, it means we are dealing with the values. All right, we want to predict the value. So the label here of the data is going to be the value. Regression always dealing with numbers. Regression, it is about predicting what is the car price in 5 years time. Like Toyota, like segment C, for example, without names, no marketing for Toyota. All right, what is the price of this car going to be like in 5 years time? Or you have a car, and the car, this is a second-hand car, and you want to predict the price. You are selling the car, you are looking for a new car, you want to sell your car. So what you can build a model, and that model going to predict for you the current price of the car. So you are going to sell the car at the best price. When it comes to regression, we should talk about the cryptocurrency, and we should talk about the stock market. These are like the trend, and there's a huge demand on them currently for people to make money from those, I would say, business. Regression can predict for you when is the best time to buy the stock market, when is the best time to sell the stock market, when is the best time to hold on. Same goes for the cryptocurrency. This is all under regression. Another part under the supervised machine learning, it is the classification. The classification, it is about to find the label of the data. Classification can deal with the number and can deal also with the label. Okay, all right. So classification can predict for you what is the weather like tomorrow. Is it going to be sunny? Is it going to be a rainy, cloudy, gloomy, hot, cold? So this is about the classification. The classification is going to be to label the data. We have a lot of data and images, and those images related to animals. Then classification going to be automatically able to label those images. The cat is considered as a cat, the dog is considered as a dog, bird is considered as a bird, and so on. Okay, so this is the supervised machine learning, and these are some of the applications: the tax fair, house pricing, and when it comes to classification, we have the sentiment analysis, which is to predict the mood or the behavior of customers, and the spam filtering. Spam filtering, I think all of you or all of us are using this application. When it comes to spam, we receive emails, all right, and you can see like sometimes automatically the email will be considered as a spam or considered as a junk email, and this is based on the classification. So the email will come, and the predictive model under classification will be able to consider which email is a spam or which email is not a spam. Or sometimes we call it which email is a spam, which email is a ham, which is the normal email. All right, moving forward is unsupervised machine learning. Unsupervised machine learning, it means the the data that we have no idea about the data, or we don't know what is the label of the data. So we use unsupervised machine learning to cluster, to group the data into groups, and those groups, why they are together, why the data they come together in one group, because they have the same features, they share the same contents. So that's why they become into a group. Like, for example, now if you look at your mobile device, I'm sure you have thousands of images, and those images could be for food, could be for your Wi-Fi and selfie, could be for like places that you have traveled to, could be for like some hobbies that you like to do. But the content of those images vary from one image to another. If we use unsupervised machine learning model on your images, then you will see all the images of food will become together, all the images of your Wi-Fi become together, the selfie will become together, the other, like the place that you like, for example, you went to Europe, you visit France. So all of the photos that when you were in France, they become together, and so on. So this is the unsupervised machine learning. So that's why we call it self-sufficient in learning. And this is when we talk about unsupervised machine learning, it means we talk about the clustering and association. And when it comes to clustering, we talk about the most common project or model under unsupervised machine learning. It is the customer segmentation, or it is the how to group the customer into group based on maybe their spending, based on their income, based on their age, based on the items that normally they buy. And these are definitely for the sake of marketing. Anyway, moving forward, it is the semi-supervised machine learning. The semi-supervised machine learning, it is the most interesting one currently. Why? Because we have a huge amount of data, and 80% of this data considered as unstructured data. Unstructured data, it means not labeled. All right. One of the things about unstructured data is not labeled. So what is the semi-supervised machine learning about? It is about combining or using both supervised machine learning and unsupervised machine learning together to build a model. All right. So an example of that. So we have like 1 million images, and all of those images are not labeled, right? So it's quite difficult to label 1 million images. What about if we label 100 of them? I think it's going to be easy to label 100 of them by expert. So 100 of them are going to be labeled correctly, and they are going to be randomly in those 1 million images. All right. So we are going to have 1 million images. Only 100 of them are labeled. The rest are not labeled. So first of all, what we are going to do, we are going to use unsupervised machine learning. So we are going to cluster and group those images into groups based on their similarity. So definitely in each group, we are going to have very few images are labeled. That label can be used for the whole group. All right. At the end of this model, we are going to be able to label the 1 million images. All right. Automatically. So this is the semi-supervised machine learning, and this is one example of the semi-supervised machine learning. Then the last one, it is the reinforcement learning. Reinforcement learning, it is about building a model, and that model going to learn from the mistakes. And why to learn from the mistakes? To avoid those mistakes again. One of the application of the reinforcement learning, it is the self-driving car, or the drones, or the auto parking, or the anything that related to the auto pathing. So the model will learn from the mistakes and will avoid the mistakes. Again, the good thing about the computer will never forget the mistake. Not like us, we may forget and we do the mistakes again. But the computer machine will never forget the mistake. Then that's why the current models, especially when it comes to the auto braking, lane detection, self-driving car, auto pathing, auto parking, now the performance of those models are very high. And I believe in the future, we are going to face and see even better performance of those models. And it was said that by 2030, we are going to have cars to drive us. We are not going to drive the car. So the car will be 100% automatically driving us to any place that we want to go. All right. Then moving forward from the type of the machine learning to the types of the deep learning. And when you talk about the types of the deep learning, you may ask, we have only one algorithm. So why do we have those types of the, but deep learning, it's about only the artificial neural network, right? So why we have types of the deep learning? We have types of deep learning because deep learning become into types because of the applications of using that algorithm, and because of the way of implementing the algorithm with the parameters, with the activation functions, and so on. So that's why we have types of the deep learning. I believe the types of deep learning could be even more than those 5 types. Like the recent article I read, like last week, I think, they said now there are 11 types of the deep learning. But I'm going to share with you those 5 to have a good, quick understanding about the types of the deep learning. And I believe later on in the future, you can dive into deep learning more and you can understand others easily. The first one, it is the artificial neural network, ANN, and this one is for the text and image data. The other one, which is the most common, we call it the CNN, the convolution neural network. This is anything that related to image, like the facial expression, like the object detection. Like you can see now is like you can build a model and use that model by the CCTV, and the CCTV will recognize faces, will recognize cars, will recognize motorbike, will recognize bicycles, and so on. All right. Another one, it is the recursive neural network, RNN, and this one is for a field which is also considered on high demand currently. We call it the NLP, natural language processing. Natural language processing, that anything that related to the text. Natural language processing, it is about analyzing our comments on social media. Natural language processing about analyzing our messages to know what is our mood, and this is the customer behavior or the human behavior. And this is under something we call it sentiment analysis also. Just now I mentioned it in the supervised machine learning. All right, and the other one, it is the deep neural network, DNN. And this one is very interesting because this algorithm can predict for you the best music background based on the contents that you have. So that's why normally we use it when it comes to movie montage. I personally, I use it before. I use the applications of that model, and I can see it is very creative. First of all, it's like automatically it create for you the movie montage based on the few scenes that you have, and will choose for you the right background based on the movements and based on the graphics of the movies that you have. Sometimes they can also provide you options of the sounds, then you can choose the right one that you have. If you are familiar with the GoPro camera, or if you're familiar with anything that related to GoPro camera, you can see a lot of mobile apps currently available, and those apps will automatically create a music background for you. The fifth one, which is the deep belief network, and this is about something related to the video and motion detection. If you're familiar with the CCTV and the DVR, which is the device that come with the CCTV, sometimes they provide, especially the recent one, they provide some softwares, and those softwares will study all the motions and the videos, and if there is any unusual movement or motion in the videos, you can see will be linked to the alarm system, or will be linked to your like phone number. Then they will send you a message, and so on. And this is for the security reason. All right. So just to continue a little bit before our first break, or before our break, talking about all of those algorithms, talking about the types, talking about being data scientists, and all of the knowledge that we share so far, then just to let you know that the amount of data going to continuously increase, and they call data as the new oil. You can see like how huge is the demand on data, and believe me, data as a new oil. This article, it was published in 2016. So since then, it was predicted that data is going to be the new oil. The amount of data is going to exponentially increase. Now we are in 2022, and now we are still in the era of 4G. We didn't move to 5G yet. China, they are going to move to the 6G. And all of those G is about increasing the speed of transferring the data that we have. So that will cause of a huge increase in the amount of data, because the speed of transferring the data is going to be much faster. So we are going to create more data. Businesses, industries, education, healthcare, any company, they are going also to increase the amount of data. They are going to, like, the generated data is going to increase. All right. Then, talking about the people who are working in this field, which are the data scientists. Currently, this is I think this is, if I'm not mistaken, this is in the second half of last year. This is a study to show the average salary of data scientists, not junior data scientists, not senior data scientists. Now, I believe in the United States, they are offering also a senior data scientist, because they start offering data scientists since 2017, 2018, since then. So now they are looking for those who are have already 4 years experience being a data scientist, which are the senior data scientists. So you can see the average salary of the data scientist is quite high. Data scientist is considered as the job number one worldwide for the last, I would say, for the last 3 years. Recently, sometimes in some countries, maybe cloud computing become the job number one, and then data scientists become the job number two. Some other countries, they still have data scientists as a job number one. So you are going to get a job which is on the highest demand. You are going to get the job which is highly paid, and your job is going to be paid even higher than those developers. Normally, developers, to be a developer, which is a professional in coding, they need to spend at least 6 to 8 years to be a developer, to gain the title being a developer. While data scientists, and as I mentioned to you just now, data scientists, if you can practice 3 months to 1 year, you can be a professional data scientist. So within 1 year, you are going to be those who are developers, and you are going to get a job which is higher paid than developers, and you are going to get a job also on higher demand than developers. Okay, all right. So later on, after the break, I think we are going to take 10 minutes break. After the break, we are going to continue with the applications of the AI, and then we are going to build those two models, one predictive model and one descriptive model, based on one algorithm from the supervised machine learning, and another algorithm from the unsupervised machine learning. All right, so I see you after the break. I see you in 10 minutes time. Thank you.
All right. Thank you, Dr. Obey, for the sharing on the big data, the something about data scientists, and also machine learning and deep learning for the session just now. So we'll have a more interesting sessions with hands-on workshop at our second sessions. So we'll have a short break right now, around 10 minutes. And if you guys have any questions regarding data scientists, regarding AI, or anything you would like to know more from Dr. Obey, do leave your comments in the comments, and we'll answer it in the Q&A session later. So we'll have a short break now for 10 minutes, and we'll see you again at 11:30. Thank you. Welcome back to the second half of the workshop. So, in the first part of the workshop, we have Dr. Obey to share with us on big data, data scientists, some tools and platform used by data scientists, and also some knowledges about machine learning and deep learning. So, let's welcome Dr. Obey for the second part of the workshop, and let's see what's interesting knowledge that Dr. Obey will bring to us. Welcome, Doctor.
All right, thank you. Okay, thanks for having me for the second part of this workshop. Okay, so we have talked about all the understanding of machine learning, deep learning, artificial intelligence, big data, data scientists, requirements, tools. So now you may ask, what are the current applications about artificial intelligence? And why we say artificial intelligence? Because earlier we mentioned that machine learning and deep learning, both of them is considered as under artificial intelligence. All right. So if we talk about the applications of artificial intelligence, it is really a huge and very wide currently, because every industry, every field, they are using the applications of the artificial intelligence. I'm going to share with you some of the on high demand applications or sector. And it's like a kind of awareness is for us and also for the government to be aware of these technologies and to start invest in these technologies. One of the most interesting and the most common on high demand field for the how to use artificial intelligence in the healthcare system. One of the model to build is based on the historic patient data. So based on the historical data of any patient, so we can predict when the patient is going to readmit or what is the risk of readmission. And there are a lot of models, and those models being used by the healthcare and insurance companies to improve the efficiency with the budget that they have. All right. We have something we call it the fitness tracker. Fitness tracker, I think most of us currently, we are using the smartwatch. And the smartwatch, it is a good device to provide a lot of data that related to our health. How is that related to our health? Because it is related to the number of calories that you burn every day, number of steps that you move, the heartbeats. Even currently, some of those advanced smartwatches are providing the percentage of the oxygen in our body, providing also the blood pressure and many other applications. Some other models that related to the healthcare being mentioned here, like a prediction, the building a predictive model to predict the right medicine. When you talk about medicine, currently, because the huge amount of it's like the variety of companies that are providing medicines, now medicine also it works based on the race, based on the nationality. So it doesn't mean the antibiotic, the one that is going to work in the US, is going to work in Southeast Asia as well. While governments, they are still not aware of these things, they still import those kind of medicine. But at the end of the day, you can see that the effect of those medicine can be lesser comparing to other medicine. So to build such a model to help the education, to help the healthcare sector, to help the government also to import the right medicine, and then definitely is going to save a lot of money. One of the most, and many other models you can see here, and I think we are going to share with you also the slides later on. You can go through, and the video is also recorded. You can go through again. But let me share with you one of the models that recently very efficient when it comes to the healthcare. And this model, it is about to build a predictive model to predict the disease based on the geographical area. So it's going to link two data sets. One data set is based on the geographical area. Let's say like we talk about like a capital in the UK, London, or we talk about like Kuala Lumpur in Malaysia. Then based on that area and based on the history of diseases in that area, we can predict what is going to be happen in terms of diseases, or what is the diseases going to be like, could be appear in 5 years time from now, or in 2 years from now. So the government going to provide the medicine, or at least enough medicine that related to that disease, and at the same time going to improve the infrastructure of the hospitals and the clinics to occupy that kind of disease. Or at the same time they can work on a different strategy, which is to try to avoid that disease to be happen in that area. Okay, so you can see how the artificial intelligence algorithm work and invest and provide services when it comes to the healthcare. Another interesting sector to invest artificial intelligence algorithm in it, which is the education system. Education system, we can use a predictive model to automate tasks. Automating tasks, it means like can automate the marking, can automate a lot of things that related to the marking. And why we are automating those marking system, using those automative marking system. It is to speed up the process of providing marks to students, and at the same time those models are going to be more precise than the human interaction. Another model, it is to personalized learning. Personalizing the learning, it is about each student. Definitely they have different way of understanding things, they have different way in learning, they have different way in understanding and absorbing the knowledge. That model is going to study the student behavior, and based on that study, different materials, different contents going to provide to that students to improve the studying part and to improve the way of gaining the knowledge and understanding the knowledge. Smart contents creation. When we talk about smart contents creation, then we should talk a little bit about the advantages of using immersive technology. When we talk about immersive technology, then we talk about augmented reality, we talk about virtual reality, we talk about extended reality, and how those techniques now prove and shown the very very good way to improve the education system. Because first of all, the interaction. When it comes to augmented reality and when it comes to virtual reality, students, they can interact with the graphics that they have, and that interaction will generate the learning. So that interaction with the graphics will automatically make the students learn in a faster and more efficient way. And many other services when it comes to AI in education. One of them also the 24/7 assistants, and that one, it comes something we call it the chatbot. If you are not if you're not aware of the chatbot, some of the application of the chatbot, when you go to the website, you will see there is like a navigator will be normally on the right side bottom to pop up, and that one is going to be for you to write the questions, and you are going to get the answers. Before, we used to have a human sit behind the desk and going to answer your questions. Now we have AI, artificial intelligence, to answer your questions. And that kind of chatbot, that one we call it the chatbot, that kind of chatbot, we can also use it for the education, and we can use it for answering student questions, and many other tasks can be implemented when it comes to the education. All right, moving from education to the something related to business. One of them, it is the e-commerce. E-commerce, because of the pandemic, I believe it was a huge development in the e-commerce sites. And now also we are in the era of doing everything online. It's not only our shopping online, we do even our work online. We do learning also online. So artificial intelligence, when it comes to the e-commerce sites, they can predict for you the trend. They can predict for you, okay, which item going to be on high demand in 6 months from now. So if you are doing this business, then you can start to store or offer this item on your e-commerce site. Price optimization. It is, I think the first one who started the price optimization was Amazon in the US. And that one is about to predicting what is the best price to be. And Amazon, they can predict the best price every 10 or 15 minutes. So they compare their price with the Walmart, which is the biggest competitor in the US to Amazon. And they can predict, okay, what is the demand on the any particular item. Then based on that, they are going to provide the best price to the customer, because they want to be always a good competitor to any other e-commerce site. Forecasting the forecasted demand, and this is what we said about the items that are going to be on high demand. Personalized store, this is based on the clustering and supervised machine learning. So each store, based on the items, will be clustered under a category. So those may be something related to the cost per part, some others related maybe to the fashion, some others may be related to any men or women accessories, and so on. Customer service, it is about building a recommender system, and we said recommender system to recommend to you items that are related to what you normally buy, or what normally on high demand in your area. Generate sales, this one definitely comes when it is about marketing. It's about how to improve the sales, how to predict which customer is going to buy from you, which customer is not going to buy from you, and so on. All right, AI for the government. When you talk about AI for the government, I think definitely we have these models improving the security system, crime prediction, weather forecasting, drug evaluation, tax compliance, and many other projects, many other models currently good to be used for the government. And one more thing, I would like to build an awareness for the government, and why I want to build this awareness. When it comes to government, government is considered as sorry, government government is considered as the best source for big data, because all the government offices under the government, definitely, and even the private sector also under the government. So they are considered as the best source for big data. So first of all, they have to invest in the big data. They have to start investing in the big data because the current infrastructure of any country, not only Malaysia, any country, the infrastructure cannot be improved unless if you use technology now and if you invest in the big data. All right, this is the way, and this era is about using the AI and the big data together to improving the infrastructure of any country. At the same time, it is good practice if the government they can provide samples of the data that they have. Definitely, they cannot provide the whole data because it's still considered as a privacy. Data is considered as a privacy, but they can provide sample of the data that they have, All right, and the data could be something related to education, something related to finance, something related to law, medical, healthcare, whatever, and all the other sectors. And that part of the data can be provided, can be offered to the private sector. So the private sector going to invest in this sample of the data, going to build a model to improve the private sector return and performance, and at the same time these models going to help the government to improve and build the better models in a faster way. AI AI application when it comes to media and entertainment, I think most of us using a type of social media, or maybe we're using all the types of the social media. I believe some of us are very into social media platforms, like we use Facebook, Instagram, Pinterest, TikTok, Snapchat. I don't know, every day we have a new one for us because we love entertainment. Anyway, so the usage of AI based on this entertainment, based on these social media or entertainment platforms, then you can see there's a huge amount and a huge demand on something we call it Facebook ads, which is to advertise on Facebook and to use that platform and for business to sell products or to sell some of the services. So that's why you can see sorry, so that's why you can see when you browse your profile, you are going to receive and you are going to see a lot of ads. And this one, when it comes to ads, and the idea and the aim of those ads to sell and to improve the sale of those who are selling on media. One more thing, when it comes to social media, now the social media provider they use AI models to work on their customer. Like one of them called the deep fake. Deep fake, it is a model based on deep learning. It was developed by Facebook, and that model is working currently on the videos that we post on social media. That model has accuracy rate of 80 something, 80, if I'm not mistaken, 86 point something accuracy rate, and detect which video is fake and which video is real. All right. Another model, it is the deep text. Deep text also based on deep learning, and that model, it was also developed by Facebook, and the model is going to analyze our comments, our likes, our write-up normally on social media, and they use that model to predict which customer on Facebook might come as suicide. It is a very common cases in the US. Those people, before they come as suicide, will post on Facebook something weird, something maybe related. So the Facebook will automatically detect that and will automatically send an alarm to the nearest security system, and then they will try to prevent that person to commit suicide. And that model shows a very good result so far. I believe it's still only in the US, it's still not applicable in other countries, but I believe in the future they might also make it applicable in other countries. And many other models like Gmail, they are going to classify your email either spam or ham. And even the spam, even the normal email, you can see now we have three categories: something related to social media, something related to the promotions, and some other emails that related to our emails that we are looking for. All right. Then one more thing, it is the artificial intelligence and the IoT. When we talk about IoT, means we talk about Internet of Things. You can see now we have a lot of devices. They are connected to each other via the microwave signal, which is the internet or the Bluetooth, and we are controlling each other by one of each other. Like for example, you can use a mobile device now to on the fan. You can use mobile device to on the a light in your house. You can use a mobile device to on the kettle, to cook, and to control the washing machine. And there's something we call it the smart house. And the smart house can be like you can control everything by a remote or control everything by your mobile device. You can use mobile app also to control your car and so on. So this is the applications of the artificial intelligence, and this is the technology of Internet of Things. And we will see how that related when it comes to IR for 5.0. All right. So before we end up the applications of the artificial intelligence, let's look at one day applications of AI in our daily life. So at the morning when we leave to go to our office, most of the time we use a navigator. Navigator is considered as artificial intelligence, the applications of artificial intelligence involved in it. We might use the self-driving car. All right. If we are not using the self-driving car, we might use a car comes with a driving assistant, which is also based on the artificial intelligence applications, or a car comes with the with the lane detection, or any definitely our cars currently, all of them are artificial intelligence being implemented there. Every day we use text messages. Text messages, artificial intelligence are involved there for at least for the auto typing, all right, or the auto correction. We use also a lot of devices to do the facial recognition. We use a lot of transactions daily, applications of the artificial intelligence when it comes to transactions, going to help us to prevent all the fake transaction. We use social media, and all of the social media artificial intelligence are involved there. And then we use smart houses, or we use devices that are connected to another device via the internet, and the applications of artificial intelligence are implemented in both of them. All right. And these are only like very simple applications or very simple usage of the artificial intelligence in our daily life. If you try tomorrow morning when you wake up, try just to look at your surround, and you can see how huge like amount of the things that you have based on artificial intelligence. Not only your device, everything now we do based on the artificial intelligence. If we walk outside, we are using artificial intelligence. You may surprise, but when you walk outside, many CCTVs capturing your movements, capturing your face, capturing the places that you go, and all of those can be implemented later on by the artificial intelligence to know our daily movements. And that's why now Google and all of those applications, they can predict our movement, and they can predict what we are going to do even before we plan. Like they can predict for you next weekend where you are going to have your lunch, or next trip where it's going to be. All right, that, and before even we plan, like for example, I didn't even plan my next trip is going to be where, but the model artificial intelligence can predict that maybe next few months I'm going to go to this country, after that country, and so on. All right. So talking about artificial intelligence, it means talking about the Industry Revolution 4.0. What is the Industry Revolution 4.0? Industry Revolution 4.0, it is about digital transformation and automation. Digital transformation, you can see now we are moving to make everything digital. We are using less papers, we are using less documents, we are using also less money cash. Even our transactions, our buying now, everything is either by the mobile app or by the card. All right. Many offices, many industries now, they are moving to digitalize their documents. They don't want to use any document. They don't want to use forms. Everything become online. One of the digital transformation is the e-government. E-government is considered as an application of the digital transformation. All right. Then we talk about digital. We say digital transformation and automation. Automation, it means artificial intelligence. We are automating things going to help us to improve our daily life, to improve the services to serve us better, to improve things, to be more precise. So as long as everything become digital, and those things become digital means what? Means data. So we use artificial intelligence to work on this data. And this is what we call the automation. Now we are in this era. So that's why there's a very huge demand on artificial intelligence and people working in this field, like data scientists, data analysts, using the machine learning, using the computer programming language, data analytics, data analysis, and all of these things. So what is going to be next? Next is going to be the IR 5.0. We are moving step by step to IR 5.0. I will share with you an example of the IR 5.0. But what is the IR 5.0 first? IR 5.0, it is about IoT, Internet of Things, and then the big data. If you ask me personally, I would say big data is the umbrella of all. So because of the big data, we are using artificial intelligence. Because of the big data, we are using machine learning and deep learning and computer programming language. We do data analysis, data analytics, and all of those things. This is all because of the big data. All right. And the amount of data will going to be exponentially increase and will never stop. So that's why IR 4.0 is going to be all about big data and IoT. Why IoT? Because we are going to use devices to be a replacement of the human interaction. All right. If you go some of the restaurants, even now in Malaysia, you can see they replace the waiter and the waitress by a machine which is going to deliver the food to you. Could be a robot, could be a machine that to deliver food to you, or can be also take your order and deliver the food to you. We are going to replace receptionist by robot, looks like a human, can be 99.9% like a human, and they can interact with us, but they are machine. All right. Two things about this replacement or about the IR for 5.0. Why we are going to replace a human? All right. Or why we having this technology? For the sake of having better services, for the sake of being more precise. All right. And for the sake of using the technology. You may ask, so a lot of people, they are going to lose their job. We cannot say a lot of people, they are going to lose their job. We can say a lot of jobs going to be obsolete. Definitely a lot of jobs going to be obsolete. A lot of it's not a lot of, less of a human interaction going to be in the future. But at the same time, this technology going to provide much more job opportunities than the job opportunities that going to be terminated or going to be like on very less demand. This is the fact about technology. Every technology, definitely, when it comes, jobs going to be, some of the jobs going to be on less demand, and many other jobs which consider as much more, triple more, 10 times more, a new jobs going to be provided in the market. The only thing that we have to move from our comfort zone. Don't be always in the comfort zone. We have to move from our comfort zone. We have to learn about this technology and then how to work in this field. So this is the idea. So I always ask about the human replacement, less jobs, jobs going to be terminated. We are not going to have a job. AI going to take our job. Even like you can see many fields till now. When we talk about once you say you are into AI or you are into this field, that using AI, then they feel like you are taking their job. While believe me, we like, for example, for the medical department, I did my PhD based something related to the medical department. I did something that related to the X-ray medical images for the Department of Radiology, and to help radiologists to have a better understanding about the images, X-ray images. And that time they feel like we are going to replace them. We are like taking their job. while we cannot replace the medical expertise or the medical doctors or those radiologists. We cannot replace them. Definitely the final decision has to come from them. But we are going to provide a system, we are going to provide a model to make their job easier and to make their job also more precise. So this is the understanding about the applications of artificial intelligence. It's not about replacing or replacing 100% replacement of a human or taking people's job. It is about to make things more precise and to make things easier and faster, because we are having a huge amount of data. And if we are not going to use that data, then we are going to be in the deep mess. So that data going to be very negative, going to provide us a very negative effect, very negative could be a response also if we don't use that data to improve our system and to improve our infrastructure. All right, so now we are moving completely from the theory part or from the basic understandings and the fundamentals. Now we are moving to the machine learning, and we are moving to two types of machine learning, and we are going to understand one of the algorithm for each, and then we are going to build a model based on the Python programming language. All right, this is one of the books. I'm not marketing these books, but I just found this book is quite interesting for people who are fresh to this field, or for people who have like maybe have some basics, or maybe after this workshop, I believe this book is going to be good for you to start to read with. All right, it's a hands-on introduction to data science. It's, I think, 2021. And this book's, the author of this book is considered as a professor in the university in the US. Sorry, I forgot the name of the university. So it is a quite academic book, but yet it is also related to the industry. All right. So in this book mentioned two types of the machine learning: supervised and unsupervised machine learning, and these are the types. And this is what we mentioned earlier under the type of the machine learning. And just a quick one again under the types of the machine learning. When we talk about the supervised machine learning, we understood just now what is the meaning of the supervised machine learning. So this is an example of the supervised machine learning. We have these images, and all of these images are apples. All right. Then we are going to how to build the model. The model is not going to look at the image and understand this is apple. No, we are going to create features. We are going to extract features from those images. All right. And the model is going to understand this feature related to this label. All right. And this is what we call it learning. So all of those features, like the green color, the round shape, and other features, all of those features means apple. The label is apple. So we are telling the model these features are apple. So the model is going to label the unlabeled image. So a new image coming, this is also apple. Then feature going to be extracted. Then the model is going to look at the features. Is it related to what the model learned earlier? If it is related, then the model will automatically label this image as an apple. This is the supervised. Unsupervised. So we have images of these fruits, and then we are going to extract the features. Then definitely the features of those images, the one that for apple is totally different than the one for banana, and totally different than the one for the grapes. So that's why this model is going to combine the features that they are related to each other, or they are similar to each other, together. As a result of combining those features, then we are going to have a group of grapes, a group of bananas, and a group of apples. All right. This is the semi-supervised machine learning. Semi-supervised machine learning is going to be clustering the images first and then labeling the images based on the label that we are going to find in each group. Reinforcement learning. Reinforcement learning, we have a model, and the model is going to respond for an action. Like we have an apple image, and then the model is going to say, as a response, this is a banana. So is it wrong or right? This is wrong. So there's an agent, and the agent will give a feedback. No, this is wrong. So the model is going to learn from this mistake. So next time is not going to address this image as a banana, going to address image maybe something else and get another mistake, learn from that mistake, or going to address this image as an apple, then this one is going to be is correct. The agent will tell the model, okay, this is a correct answer, and the model will gain +1. This model, the main purpose of this model, to keep gaining +1, so to be less punished for the mistake. All right, so that model is going to provide always the right answer, or doing the right action. Okay, so we are going to focus on the supervised machine learning and unsupervised machine learning. So what is the difference between, or what is the main difference between supervised machine learning and unsupervised machine learning? First of all, when it comes to supervised machine learning, so it means we are talking about classification and regression. And I think I shared with you just now. Classification, it is about labeling the unlabeled data. Regression, it is about to predict the value. Classification, we can deal with numbers and we can deal with categorical value. We talk about the categorical value, right? And then regression is only dealing with numbers. All right. Unsupervised machine learning, it means we are doing clustering. We don't have any idea and we don't have the label of the data. We are going to group the data into groups based on the similarity of the features. When it comes to evaluation, supervised machine learning, we have more evaluation methods than the unsupervised machine learning. Why? Because when it comes to the supervised machine learning, we know what is the data about. When we build the model, later on I will show you, we are going to do something we call training set and testing set. So when we are going to build the model, we know this model is going to learn from the data that we have. And then we are going to check the model by predicting part of that data. All right, but we remove the label. So when the model is going to predict based on that data, so we can compare the result with the actual result, because we know the actual result of that data. All right, so that comparison is considered as the evaluation of the model. And we have also more methods to do the evaluation. When it comes to unsupervised machine learning, we have very few evaluation methods compared to the supervised machine learning. Why? Because unsupervised machine learning, we have no idea about what is the actual result, right? So that's why we have just few methods to try to guess what is the actual result. Like, for example, we have a data, and the data, we are going to group it in 5 groups. But we have no idea what is supposed to be the actual group of that data. Maybe should be 10 groups, should be 7 groups, should be 2 groups. We don't have any idea. So it's quite difficult to evaluate the unsupervised machine learning. All right. Then the most interesting thing and the most help, I would say, for data scientists, those tools. So again, I would love to emphasize on those tools, and I would love to keep telling you this, because you don't have to worry. A lot of people, when they come to data scientists, they feel data scientists is something that it is going to be impossible for them to make it, because they have to learn math, they have to learn statistics, they have to learn codes. But you don't have to worry. All of those tools are going to help you. You just need to learn how to use them. All right. I have trained people coming from law, and they are very good data scientists now. You know, when it comes to law, normally during their study, they don't study coding, they don't study math, they don't study statistics, because their field is something totally different. But now they are very efficient and they are successful data scientists in their field. I have trained people who are medical doctors. All right. Definitely medical doctors also, they don't study coding or statistics or math. But now they are able to be data scientists in their field. I have trained people which are coming from education, coming from finance, coming from mechanical engineering, architecture, civil engineering, many other fields. I have trained people also with a diploma or just only school. At the end of the day, they make it, and they are working in this field, and they are improving step by step. All right, so you just need to learn about these tools. This is one of them, is an NumPy, and this library has a lot of functions to deal with the data set, to deal with the rows and columns. When you talk about data set, it means we are talking about rows and columns, right? So it means matrix. So this library can do for you everything that related to matrix. You don't have to do any math. Even you don't really have to understand what is going on. You just need to know how to use the functions inside this library. Another one is a SciPy, and it works also on the rows and columns, but for the different purposes. Matplotlib. Matplotlib is one of the most common data visualization library for any data scientist. All right, it is simple. It is straightforward. You can learn how to use it step by step, and you can visualize the data in a very efficient way. Another one, and this one is a well-known when it comes to data science, data scientists and data science, it is Pandas. Pandas, it is the way of reading the data set into a data frame, which is rows and columns. Later on, I will show you by the coding how we are going to look at the rows and columns. And it is also to do a lot of statistical measurements on the data set. Another one, it is the scikit-learn. Scikit-learn, it is, as I mentioned to you earlier, it is the most common algorithmic library for data scientists for machine learning. And the good thing about the scikit-learn now, scikit-learn also, they come with a lot of data sets for training. They come with the evaluation methods, and they come with a lot of other tools. You may need them later on to build a model. All right, and by the way, all of those libraries, all of those tools, Python programming language, all of them are free for you. They comes with the free copyright, free lifetime copyright. All right, so, and at the same time, and I have to emphasize on this as well, please try not to memorize any code. Please try to understand how to use the code. Try to understand how the computer programming language works. Don't learn how to use it. No, learn how that programming language works. Then you are going to use it in an efficient way, and you are going to learn how to use it in a faster way. Building a predictive model. It is very simple, and it is as simple as this. First of all, you are going to do the data processing, which is the exploratory, which is the data wrangling and the exploratory data analysis. All right, and this is what we mentioned earlier. And then you are going to divide the data set into train and test. A train, you are going to use it to train the model, to make the model learn. Test, you are going to use it to evaluate the model. I will go in a bit detail shortly about the train test. You will understand it more. Then you are going to use the algorithm. So you are going to import the algorithm. As we can see here, we are importing the algorithm. This is importing support vector machine. We are going to talk about support vector machine soon. And then we are going to do fitting the model, which is to use the algorithm for the training set. And fitting the model, it means going to train the model and going to make the model learn from the training set of the data set. And then a prediction. A prediction, it is about to use the learned model to predict the label of the test set data. Why we do so? Because we want to see how good is the model in predicting the right label. So that's why after that we do evaluation. We evaluate the model. We see how precise is the model to give the right result. If the result is accepted, then we can export the model. So it means we can deploy the model on the new coming data. All right, all of these steps, and you can see we don't do much of coding. We only import. So if you ask me, I would say we do a lot of implementation when it comes to coding. We don't do coding from A to Z. All right. So for the beginners, for people into this field, my recommendation, my suggestion, my advice to start learning these algorithms. Supervised machine learning, we have regression algorithm, we have a classification algorithms, which is k-nearest neighbor, decision tree, and support vector machine. Together, we are going to understand support vector machine, and we are going to do coding for support vector machine. We are going to build a model together. Unsupervised machine learning, we have these algorithms: k-means, hierarchical, and then the DB scan, the density-based scan clustering. For the unsupervised machine learning, we are going to work together on the k-means shortly. All right, but as a beginner, as someone fresh, I would recommend and suggest to learn these algorithms and then to start practice, to start downloading data sets and building models based on these algorithms. All right, then classification. I think we have talked about the classification. I'm going to skip this slide. Classification, it is about to predict the right label of the data. So you can see we have this data set, and this data set related to a bank, and we want to predict who is going to pay the loan on time. This one, the default one, before used to be yes or no. Yes for 1, no is 0. So we convert the values to become 0, 1. And then we have this customer with these features. These columns are the features. And we want to predict whether this customer is going to be 0 or 1. All right, it's going to be no or yes. All right, so based on the learning from here. So this is about the classification, and some of the applications of the classification. We can say a lot of applications for classification, but some of them can predict the category to which customer belong. We can predict the weather. We can predict whether a customer switched to another provider or brand. We can predict whether or not a customer responds to a particular advertising campaign, email filtering. And this is like we use it currently. Facebook ads and Google ads, they use it currently when they provide ads to either to us as like a user, or to those people into business which they pay for the Google ads or the Facebook ads. Speaker recognition, handwriting, biometric identification, which is something that related either to the fingerprint or the iris, document classification, and much more. One of the very common applications also under classification, it is the image classification. All right, what about evaluation methods? And before we talk about the evaluation methods, we should talk about the train and test. So what is the train set and what is the test set? When we talk about the train set and the test set, so we have, let's say we have 100 images of photos, and all of those photos being labeled. All right, so we are going to build a model, and this model is going to learn from those 100 images, and then to use that model to label the unlabeled one, or to label the new coming data which are unlabeled. So what we need to know, how good is this model? Okay, the model is going to learn from 100 images, but we don't know whether the learning part was good or not. So what we do, we take part of that images for training and another part of those images for testing. So let's say we take 70% for training. So 70% the model going to learn from those images. And then the 30 images that we have for testing, what we are going to do, we are going to duplicate them. All right. Then we are going to remove one of the duplication. We are going to remove the label, and we are going to consider it as a new coming data to the model after learned from the 70 images. All right. Then the model is going to do what? The model is going to predict the label of those 30 images. Then that prediction or those results that being predicted by the model is going to be compared to the other duplication. The other duplication still with the right label, right? So the predicted one going to be compared to the actual result. All right, and we can see like how many images being predicted in the right way. All right, then that one we'll consider as the evaluation. So that's why we have a train and we have a test set. Okay, I'm going to skip this. This one is about, we should have something we call it a train test split. So we have a training part for training and we have part for testing. It's not about building a model and the whole data set is going to be used for the training. And then after that, we take part of it for testing. That part for testing is already being used during the training. Then definitely the model is going to provide a very good result because those data being used. So what do we use? We split them. So the part for testing is totally different than the part for training. But you may ask, or sometimes the people in this field, they ask, so it means I'm going to build a model, and the model is not being trained by the whole data. We need to use the model to be trained for the whole data. So what do? We use something we call it cross-validation. The cross-validation, it is about like to run the model for evaluation more than one time. But each time, we are going to take a part for training and different part for testing. Like, for example, here we have, this is the for cross-validation. So you can see for the first part, what we took. We took the first 25% of the data for testing and the rest of the data for training. Then we calculate the result, which is 80%. And then for the second run, we took the second 25% for testing, all right, and the rest of the data for training. Then we calculate the result. And then the third fold, we took the third 25% of the data for testing, and the rest for training, and then the last part of the data set for testing and the rest for training. So you can see at the end, the model being trained with the whole data, but each time different part for testing and different part for training. And then the total accuracy rate is going to be the average of those four accuracy rate. All right. Then you may ask, so what about so that is how to divide the data set, and that one is only for a predictive model. So to do that, train test split is only for building a predictive model. All right. Normally we don't do that when we have a descriptive model. Then what are the evaluation methods? The most common evaluation methods when it comes to classification, it is the Jaccard index, F1 score, which is based on the confusion matrix, and then the log loss. So a quick one, what is the Jaccard index? The Jaccard index believe, all right, evaluation should be the intersection between the predicted result and the actual result divided by both of them, the combination of both of them. So as you can see here, this is the orange color is considered as the actual result. The green color is considered as the predicted result. All right. So what is the intersection? What is the common item between them? Going to be divided by the combination of both of them. So the result is going to be this result is going to be the accuracy of the model. And definitely the higher, the better. All right. The other one, which is the most common one, we call it the F1 score. F1 score is based on the confusion matrix. Confusion matrix, it is about to see what is the true predicted, all right, and what is the false predicted. So you can see in this example here, what do we have? We have 100 label, all right, and those labels are divided to N, which is negative, and P, which is positive. All right, and they are equal to each other. So we have 50 for the N negative, and we have 50 for the positive. All right, then the rows consider as the actual value, and the columns consider as the predicted value. So when it comes to this cell, all right, this cell is the predicted negative. So anything predicted negative in this cell, anything predicted in this cell is considered as a truly predicted N, a truly predicted negative. We have 40 item, all right, 40 label were predicted as N. So this one is considered as true negative. Why? Because this is the actual one is negative, and it was predicted as negative, then this one is a true negative. Then the same row, we have had 10 label predicted as positive, while this one is not positive. This one is considered as negative. So that's why this one is wrongly predicted positive. So that's why we call it false positive, FP, false positive. All right? Then here, this one is considered as P. So anything in this cell is going to be predicted as N, while this one is P. So this is wrongly predicted N. So that's why we call it false negative. So wrongly predicted as negative is FP. And this cell, it is predicted as positive, and at the same time, yes, it is a positive. So that's why this one is a true positive. I don't want to go into more details. I don't want to make things difficult for you, but this one is the diagonal here is considered as the accuracy rate of such a model. And this matrix here, we call it the confusion matrix. And from the confusion matrix, we calculate something, we call it the F1 score. And the F1 score based on this equation, and the terms here, precision and recall, comes from these equations, is true positive divided by true positive plus false positive, and so on. Anyway, when you do the coding, everything is going to be done behind the scene of coding. You are not going to do all of these things, but this is for you to understand what is going on. Okay, all right, and the last one, it is the log loss. The log loss, it is related to the prediction of the category, like here, all right? And this one is going to check, okay, sorry, for the confusion matrix, also the number is like when the higher is better. Log loss, it is about to predict, is like what is the probability of each prediction, all right? Or how wrong is the probability of each prediction. Okay, so that's why, as a result of the log loss, it is the lower number, it means the higher accuracy, because it's like predicting like how wrong is the prediction was in each category or in each label. Okay, so those about the methods of the evaluation. Then moving forward, we are going to talk about support vector machine and k-means. Support vector machine, it is one of the most sophisticated algorithm under supervised machine learning to build a predictive model. All right, and why it is a sophisticated? Because this algorithm, it comes with the kernels, it comes with those parameters which able to transfer the data in a way to find the best separator by the data. So once you find the best separator by the data, then the algorithm is going to predict the right label for the new coming data. Like for example, this data set is related to a medical department. This one is to predict which cell is cancerous and which cell is not cancerous, which cell is benign and which cell is malignant. All right, cancerous or not cancerous. So you can see all the yellow is considered as benign, and all the blue considered as malignant. All right, this line is considered as non-linear line, and this line was generated by the algorithm. All right, to see like how good is this algorithm, support vector machine, to divide the data set into two groups. Then any new coming data, it is going to be easily known whether should take the yellow color or take the blue color. So if the data point is here, then this one belongs to the yellow color. If the data point is here, you can see how close, then this one is going to belong to the blue color to predict the right label. And at the same time, this algorithm are able to transfer the data into high dimension and then to find this separator. So you can see all the blue are up and all the yellow are down, and this is the separator. And this one is to improve the accuracy result of this algorithm. So that's why we call this algorithm is considered as the most sophisticated algorithm when it comes to the supervised machine learning. Okay, so what about if the data is like that? So you can see this is two labels. If you look at it, we have the red label and we have the blue label. So how to differentiate? And they come in like in one line. Subpar vector machine, by this kerneling, we have the linear, polynomial, RBF, sigmoid is going to automatically, you don't have to worry about them. You don't have to go deeply to learn them because everything is done by the coding. You can see the data being transformed in this shape. And now this line is considered as the separator of those two categories or those two labels. All right. One more thing about subpar vector machine, or one more example about subpar vector machine to understand subpar vector machine algorithm. We can see this data set, and these are the data labels by using this visualization. This one we call it the scatter plot. This is the y-axis, this is the x-axis, and you can see we have this label and we have this label and we have this data. So this data is belong to which one? You can see it's like it's quite confusing. This one is it the blue one, or is it because is it belongs to the red one? Subpar vector machine is going to build such a line, and this line is considered as the base separator. And at the same time, subpar vector machine build also something we call it the margin. So the margin is like how big is the gap from the base separator line to the next data point to this line. So you can see this one is considered as the margin. Here is also considered as a margin. So when the margin is bigger, the accuracy is going to be better and higher. So this is about the subpar vector machine. This is a quick understanding about the subpar vector machine. If you ask me personally, let me share with you the truth. You don't have to understand the algorithm. Why? Because everything later on done by the coding, even for those who they don't know how the algorithm works, they are going to be able to do the coding and to get the result. And at the same time, you need to understand how the algorithm works. Why? Because when you apply for a job, they will ask you the theory questions for data scientists during the interview. You are going to have a lot of questions that are related to those algorithms. So you need to understand how the algorithm works. You don't have to go into detail of the math and the statistics behind it. Definitely, they are not going to ask you about the equations, unless if you are going to work as algorithm developer, then definitely you have to go through the math and the statistics behind it. You are going to just use them. So it's good to understand them, understand the basic, because if you are going to apply for a job. All right, the advantage and the disadvantage of the subpar vector machine. I believe subpar vector machine is considered as memory efficient and considered as working efficiently when we have high dimensional because of the kerneling. But some of the disadvantage, there is, I say, a small data sets. I don't think we have enough time why subpar vector machine considered as working on the small data sets, or why machine learning considered as compared to deep learning, definitely working on the small data sets. Just a quick one, because deep learning, the performance of the deep learning will improve, will get higher when the more data you have. But for the machine learning, there's a level when machine learning will stop performing, like showing a good performance when the data increase. So that's why we say in the future, we are going to have more applications of the deep learning than machine learning, because the data will exponentially increase. I have a video here, more details about the subpar vector machine algorithm. I'm going to leave it for you later on to watch it when we are going to share with you the slides. And then moving forward, I'm going to share with you the understanding of this algorithm k-means, then we will do the coding. As long as we are going to talk about k-means, means we are going to talk about the clustering. And we say the clustering, we already mentioned clustering, it's about grouping the data into groups based on the similarity of the features. And you can see here, we have this data set based on like some of the features. We are going to group them into these groups. Looking at the data sets, we have these data points, and you can see how we are grouping the data into these groups. So how k-means works, or before that, what are the applications of the clustering? Applications of the clustering are more wide than the applications of the supervised machine learning. Why? Because we said most of the data that we have is considered as unlabeled data. All right. Sorry, it's considered as messy data, which definitely unlabeled data. So that's why we have more applications of the unsupervised machine learning than the supervised machine learning. And when it comes to the unsupervised machine learning, then retail and marketing, and this is about the customer segmentation, banking, about the fraud detection, insurance, about the also the fraud detection of those who want to claim for the fraud, accident or health care, publication, medicine, biology, and many other applications. And even we can use a clustering also for the exploratory data analysis. All right. So the first algorithm, which is the k-means. K-means, it is the algorithm that allow you to divide your data or data set to manually choose a number of categories. So you are going to choose the number of the categories. You are not going to like let the algorithm automatically divided the data set into groups or clusters. You have to choose manually. All right. So this is how it works. Is going to work based on the something we call it the distance between the data points. And when you talk about the distance between data points, it doesn't mean distance, which is the meaning of distance. No, the distance, it means the difference between the value of one feature and the value of another feature. Like, for example, we have here customer 1 and we have customer 2. In terms of the feature age, customer 1 is 39, 34, and customer 2 is 30. So what is the distance between those two customers in terms of the feature age? This is the distance, which is the gap between the values of those values of this feature between those customers. Okay. And we can use 2-dimension, we can use a 3-dimension. It means we can use more than one feature. It's not only one feature. So let's say we have these data points, and this is based on the income and the age. All right, these data points, and we want to group them into 3 groups. So how the algorithm is going to work? First of all, you have to initiate the number of clusters, which is the parameter k. Okay, so the algorithm is going to randomly generate something we call it centroids. Those centroids is considered as the center point of these 3 clusters. All right, because we want to divide this data set into 3 clusters, right? So it means we are going to have 3 centroids. So the algorithm will start automatically plot those centroids. All right, and then going to calculate the distance from each data point to each centroid. And then you can see based on this distance, the distances are not equivalent to each other. So it means the centroid are not in the right location. If they are going to generate 3 clusters, so these clusters are going to be like that. All right. So what are the algorithms? So these clusters considered as not equivalent to each other. The clusters supposed to be having the same amount of the data points for each one. So these locations of the centroid considered as not right. So the centroid will be relocated. You see, the centroid will automatically relocated. And if it is right, then it's going to generate 3 clusters. If not, then going to be relocated again. Till as a result, we are going to have these 3 clusters. All right. Again, you don't have to understand, you don't have to go into detail of this algorithm, because everything is going to be done by the coding later on, and you will see the coding shortly. But if you're applying for a job, you are going to get a lot of questions that related to this algorithm. Then it's good if you can understand how the algorithm works. All right, I'm going to stop the sharing. I'm going to share with you the coding part. So just a minute. Okay, all right. I believe you can see now the, yeah, perfect. All right. So this is the one of the project that we are going to build together. I called it a project loan. And this project, we have a data set related to bank. And this bank, they want to know whether the customer is going to pay the the installment on time or not. So when it comes to building such a model, we always follow the data science methodology. The methodology, it's about, first of all, business understanding. So what is the problem and what is the main goal and what is the main objective? The main goal, it is to solve the problem of paying the loan. The main objective, it is to build a model to predict whether the loan is going to be paid on time or not. I'm going to share with you also this file. Later on, you can run the code on your site. I believe you don't have enough time to do the coding together, and this one is going to take a long time, but I'm going to explain to you all of those codes. Then later on, you are going to be able to share it on your site, and you can use the Google Colab. This is considered as one of the virtual lab that normally we use for training for data scientists. You don't have to install any software. This one also is considered as a free tool, free copyright, free lifetime copyright. So you just go to any browser, preferable to use a Chrome, then you search for Google Colab, this one, and you will find this is the options here. Then you click on it. You have to log in with your Gmail, and then you are going to have this interface. I believe yours is going to be, if you didn't use it before, yours is going to be empty. Then you just click on a new notebook if you want to start coding. Or if you want to run the file that I'm going to share with you, then you go to upload, and then you upload the file that I'm going to share with you later on here. Then you start run the cells. All right. Then analytic approach, it is about choosing the right algorithm to solve the issue of this model. Data requirements, data collection, it is about what are the data that you require to solve the problem of this project. Normally the data is available, unlike before. Before, we used to archive the data and then we start working on the data. Now the data is available by all the companies. We just need people to start working on the data. So normally we don't spend that long time doing the data requirements and the data collection. Data understanding, it is about to start looking at the data set. All right, start looking at the data set. It is by importing all the needed library and start loading the data set and start to understand the data set, looking at the data set. You can see, and this data set is going to be automatically downloaded from this site, so you don't have to upload any data set. Then reading the data set, we are reading the data set by pandas. I mentioned to you pandas just now. You can see we are import pandas. Normally we import those libraries because we are going to use them. So it means we are telling Python programming language to activate those libraries because we are going to use them. So this is the data set. These are the features. Then next we are going to, and these are describe and include all. It is to have a quick statistical understanding about the data set. So you can see describe, you are going to have the mean, standard deviation, minimum, 25%, blah, 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 then maximum value. Describe and include all, you are going to have a quick understanding about all the features in the data set, not only the numerical columns. Describe without an include all, it is only about the numerical columns. Describe and include all, it is about the numerical columns and the categorical columns. Then data preparation. When it comes to data preparation, then we are going to do the data wrangling and the exploratory data analysis. So you can see here, we are going to turn some of the data time. We are going to, all the notes are here. We are going to also do some data visualization to look at the data. And then after that, we are going to select some features. We are going to do normalization. And this is, we call it one-hot encoding, which is turning categorical columns to numerical columns, and so on. All the notes here. And as long as we don't have time later on, you can always contact me if you need any, if you have any question, or if you have any, if you need any extra definition or extra understanding about these codes, please try to contact me. I will share with you I think we shared earlier. We are going to have it in the slides, my email and also my LinkedIn profile. Then you can see we also do data normalization, which I mentioned to you earlier, which is turning the data normalization or data standardization, which is turning the values to be in between 0 to 1. And then modeling. Modeling, we can use either of those algorithms, but in this project, we are using support vector machine. So you can see using support vector machine, we have the training set and the testing set, and this is the data is here. And then as a result, we do the evaluation. This is the part of the evaluation. We are using the confusion matrix, and this is the confusion matrix, same like what we shared in the slides. And we got the result almost 1. I believe if you go through these algorithms, so 1, it means 100%. If you go through these codes, you will find some like things need to be changed. Please try to go through, and you are welcome to discuss about it anytime. If you want to run all the cells, you go to this option, runtime, and then run all. So you will see it's going to be run all, and we may find a different, the same result. Anyway, you go through, and if you have any question, please come back through email, then we can discuss about it. Then as long as the model, let's say if the model is going to be okay to be used, then we are going to deploy the model. So deploying the model is to use the model on the incoming data. And after using the model on incoming data, definitely we are going to get a feedback. And those feedbacks, if positive feedbacks, so we need to improve the performance of the model. If the feedbacks are negative, then we need to solve those issues. One very important thing to share with you. Data scientists, they think once they deploy the model, it means their job done. While the real job of data scientists will start when they deploy the model. And the job of the data scientist will never end. Why? Because we always have a new coming data. A new coming data and new coming issues, we need to solve those issues, and we need to improve the performance of the model. All right? So that's why the job of the data scientist will never end. All right? So this is about the usage of the support vector machine, working on this data set. Moving forward, it is the k-means. For this project, what I did something very interesting, which is to create our own data set. All right? Because this one is considered as unsupervised machine learning, right? So we don't know what are the actual number of the categories. So what we are going to do, we are going to generate the data set, and then we are going to use the same number of the categories based on our generation, all right, of the data set. So let's see how good is this algorithm in dividing the data set on the right for the right number of clusters, if the right number of clusters was chosen. Okay, so these are the needed libraries, and here we generate a data set. We generate 7,000 sample, 7,000 dots here we have. All right, and those dots being distributed, those 7,000 being distributed based on those centers. All right, we have 1, 2, 3, 4, 5 centers. You can see 1, 2, 3, 4 centers. You can see the clusters of the data set is like 5. All right, and then the standard deviation, I chose 1. Later on, you can manipulate these numbers and you can see what are the difference going to be. All right, now I'm calling the algorithm, which is the k-means, and these are the labels, and after the labels, these are the centers, and this code, you don't have to go through this code. This one is about data visualization. Normally, some of the data visualization codes are a bit lengthy, so you can just keep it in your cheat sheet. Then later on, you can use it whenever you need to use it. You just change it based on the data or based on the project that you are working on. All right, so as a result, you can see in this code, we choose the number of the categories. We choose them 5. You can see the algorithm provide for me 5 categories, and almost like 99% exactly like how I generated the data set. So it means this algorithm is going to perform perfectly with the high efficiency if we choose the right number of the categories. But one of the like weakness, I would say, of the k-means, when we are going to choose not the right number of the clusters. Like, okay, in this code, you can practice. All right, let me run all here. I'm going to run all. Okay, this code is for you to practice with the visualization. So I put the number of clusters 10 on the same data set. You see, the algorithm provides for me 10 categories, but doesn't make any sense, right? What about if I change the number to 7? Okay, this is 7. I'm going to run this cell, and you can see now I have 7 categories: 1, 2, 3, 4, 5, 6, 7. If we compare this result with the how I initiated the data set, doesn't make any sense, right? All right, so 7 categories is considered as not the right number of the categories for this data set. Okay, but for k-means, we also have an evaluation method, and that evaluation method, we call it the elbow point. That elbow point evaluation method is considered as finding for us what is the right number of the categories to be chosen for that particular data set to be performed by the k-means. All right, but this one is quite more advanced. It's out of the scope of this workshop, but also there is a way by the evaluation to find what is the right number of the categories. These two, all right, these two projects is good to have them in your portfolio, but try to do the rewrite, try to have it in your own way, to have it in your GitHub profile. I believe this one is very interesting because you are generating the data set and you are performing the same number of the categories based on the generated data set. And this one to show your understanding, and you can argue about it, that because you want to show how good k-means in predicting the right number of the categories, and why, if the interviewer or people, they ask you why, because the unsupervised machine learning algorithms have less evaluation methods comparing to the supervised machine learning algorithm. Okay, all right. So I believe I should have finished earlier to give you like half an hour for Q&A. Now we have only like 7 minutes, so we can extend a bit if possible. So thank you so much for attending this workshop. Thank you so much for all the questions that we are going to have.
Yeah, all right. Thank you, Doctor, for the great sharing just now. So we will extend the time a bit because we actually received quite a number of questions from
Yes,
our
yes,
audience.
please.
Right.
I would love
So
to.
we'll start the first one from the Facebook from Jerway. So his question is: in terms of AI, Doctor has spoke of all possible applicants. So he would like to know, when developing AI system, what is Doctor
Mhm.
opinions on AIs being described as sentient or having developed a singularity?
All right. So this is on Facebook,
Yep.
but this is related to what kind of data set or what kind of a project?
I think
Is it?
he's asking for general AI. So, will they one day the AI develop until it can live like humans being?
Oh, okay. All right. So, so if we talk about those robots or talk about something like related to those machines, first of all, we are going to use hybrid algorithms. So just now we mentioned about reinforcement learning. We mentioned about semi-supervised, unsupervised, supervised. So later on, to have such a model, we are going to use the hybrid algorithms. So each part going to focus on a part and going to develop some kind of results. But at the same time, to have that machine or to have that that robot definitely have to be for specific instructions and for specific tasks and duties. So definitely the one that's going to be as a receptionist is totally different than the one that's going to be as a waiter or waitress. So it's not like we cannot develop something to be 100% in general like a human, but we can have them to perform precisely and to be efficient in in a certain part or in a certain task.
All right. I think that answered the questions. Then we'll have some questions from the Slido. So I think we'll start with the top question. So,
All right, how
in
can
doctor
artificial
opinion,
intelligence be used to identify fraud?
yep.
Okay, a fraud detection, either for health insurance companies or for banks, been there for quite some times, and I believe the models that we have currently, they are very efficient and their accuracy result is very high to detect the fraud detection. And in general, the model is going to always learn from what we normally buy. If there is any irregular or unrelated transaction, so that one is going to be considered as a fraud transaction. So that's why sometimes you are going to receive a message when you do a transaction. Did you do this transaction or did you buy that item or whatever? And this one is considered as for the security reason, and this is what also banks they want to use to protect their customers.
All right, understood. Then the second questions: what are the current technologies that support AI?
What current technologies that support AI? Or I would say what current technology that's supported by AI. I think like as we mentioned in the slides and the one day routine and how we are using AI. We are like using AI in every move that we make. Our mobile device also 100% based on AI, learning about our movements, learning about even like the usage of the phone. Now, a lot of statistics come by Android
Mhm.
and by iOS to show you like how much time you spend on each app or what is the usage of your data, what is the one, where do you use the data, and so on. So this is all good to build a predictive model or descriptive model to know, okay, what is our future usage, what we are going to do, where we are going to go, what we are going to buy, and so on.
All right, sure. Then I think we'll take a look at the latest question because I think it's related to if we are given the set of data, maybe the example of the loans given
Mhm.
to be analyzed, what is the outcome that we should present to client?
Okay, first of all, it's a very good question. First of all, what is the requirement by the client, or what is the problem that you are going to solve? It is to analyze the data, analyzing the data. So it's going to be data wrangling and exploratory data analysis to find some insights. So those insights can be, it's like, okay, which month was the best selling month, or which month going to be the lowest profit, or which item going is normally on high demand, which item is like it's quite difficult to sell. So those are the insights. And if the requirement or if the task it is about how to improve the profit, then we can build a predictive model to predict, okay, which month going to help us to going to like to be on high sale. Then we can like that owner or that client, they can like make more offers or make promotions. Or maybe the month that is like normally on the low sale, then they can predict which are the items that normally is quite difficult to sell. Then they can have like offers, or they can improve even their marketing plans during those months.
All right, cool. I think that answers.
A lot of machine learning models also related to marketing. We use them for better marketing. If you can see, like when it comes to business, we use machine learning also for to improve the profit of the companies.
Mhm. Then next, could you share any of your experience in an AI project or task? What are the challenges and how did you overcome them?
All right. So, any experience in AI project or task? If you ask me personally, normally I work, and even my projects and my students, they work on the medical images. All right. So, and I believe like there's a very huge demand for people who are data scientists, um, and medical department on in healthcare. The challenge is always when it comes to someone that wants to prove he or she data scientist and they want to start a job, it is the data set. So how to find the data set and how to start to practice on the data set. And even when we are get hired by the company, they are not going to trust us with the data. Definitely we need time to they need time to like build the trust and the new employee, then they can share the data step by step. So I think these are the main challenges: is the data, to have the data and start working on the data. And the common challenge, not the main challenge, it is you need time to invest, to upskill yourself, to learn whatever tools are available to be applied on the data and to get insights and to solve the issues of the data, which are all of those libraries and tools are available currently for data scientists by Python programming language.
Mm-hmm. So next, oh, here comes the new questions. Is there a sweet spot when it comes to model performance in terms of accuracy level? Can we deploy a model that doesn't have high accuracy level, says less than 70%?
Yes, definitely. This is a very good question. So sometimes it's like you cannot improve the result more than maybe 50%. Maybe 50% is also going to be accepted based on the model, based on the data set, based on um, the industry. They are okay with the 50%. While in some other models, even 90% could be not acceptable. So, like those models that are related to pharmaceutical companies, related to medical analysis, diseases of predicting of diseases, 90% could be not enough. We need to improve even more. So there is no any typical number for the accuracy rate. So we cannot say, okay, have to be more than 70 or have to be more than 90 or shouldn't be 50. It's like it's based on the models and based on the project that you are working on.
Yeah. So it's different field require different accuracy in terms of applications and all that. Is that right,
Exactly.
doctor?
Exactly.
Yeah.
Yes. Perfect.
All right. I guess we'll have the last three questions here. So,
Okay.
is AI just a hype terminology? Well, fundamentally, the concept is mathematical and some computing.
I would say yes and more. So it's definitely is all based on mathematics and based on the statistics, based on definitely computing. But now it's like a lot of involvements of visualization, of generating insights, of also archiving the data and sorting the data, cleaning the data. But we are also moving into an era, I believe, in the future, because of the demand on using AI applications, we are going to find a lot of models, ready models. You don't have to use coding. You are going to have like blocks. So here to upload the data, here to use the machine learning algorithm, here to evaluate the result. And to be honest, we have currently, but the performance of those applications is still not that high. But I think we are going to have such thing for small models or for like a quick understanding about the data.
Mm-hmm.
So the
Cool.
math and statistics of artificial intelligence going to be forgotten.
I see. More questions coming in. So next, will doctor encourage data science students to pursue Master of PhD, or is working experience will be more important?
Okay, all right. Yeah, this is a very good question. So, as a PhD holder, me myself, if you ask me, to be honest, I'm not going to study master or PhD. I'm going to make a lot of universities unhappy by this answer. I would prefer to start like mastering the skill, start mastering Python programming language, start mastering those tools and working on the data. And then definitely I'm going to make more money, because it's like when it's, at the end of the day, it's like how to make your living and how to make money. When you study master and PhD, then definitely you are going to spend more time and more money. And then after that, after you finish, even as a PhD holder, after you finish your PhD, then you still need to look for a job and start making money. All right. So this is can be one part of my answer. But when it comes to data science, the awareness and the understanding of data science, I think worldwide is still not there. So a lot of universities now, they offer data science as a bachelor or as a master or as even a PhD. While those graduates from the faculty of data science as a as a bachelor holder, as a master, as a PhD, their opportunity in the industry much better than opportunity to be a lecturer in the university. First of all, there's a high demand. It was said by the year 2026 is going to be 11.5 million job opportunity offered for those who into big data and data science worldwide. Okay, so if you are going, so the idea is if you are going to study master and PhD to move to the industry, then it is advisable to study. But if you are going to study a master or PhD in this field to be a lecturer, then I think it is quite later on it's going to be also difficult for you to find a job and to start like making money from that field.
Mm-hmm. I think that helps our audience because I believe most of them are still students. So I think that give a great advices.
I
Then
hope they are not
I think
getting confused.
yeah, sure. Then I think this new question is more technical. So for SVM, like the one Doctor showed just now, does the
Mhm.
number of clusters have to be inputted manually, or can the machine do it by itself, like try and error?
Okay, subprefecture machine is going to predict the label. All right, subprefecture machine is not going to work on the clusters, on the clustering. Okay, so like the one that you showed, does the number of clusters have to be input manually, or can the machine learning do it by itself? Okay, first of all, what we shared just now about support vector machine. Support vector machine, it is for predictive model, not for descriptive model. All right, but for advanced courses, for advanced understanding, we can use support vector machine in a hybrid way to be used for clustering. All right, there are other algorithms, all right, to be used on the data sets to automatically predict the right number of clusters. Like the one that I shared earlier, but we didn't go through because of the short time, which is the DB scan, the density-based scan. That algorithm is going to automatically predict the right number of clusters for any data set.
I hope that explained, because I'm actually not in this field, so I think really we'll have last few questions before I end this sessions.
Yes, yes.
So I guess this will be an interesting questions. Hi, Dr. Obey. I'm a student in computer science and interested to have my FYP related to AI or big data. Can I have a suggestion in what field will be more suitable for?
FYB is what?
Final year project, I guess.
Oh, finally a project. Okay, okay. Sorry.
Yeah.
Related to AI and big data, can I have your suggestion in what field will be most suitable for? And he's studying computer science.
Mm-hmm.
Okay, so this is a very good question, but to be honest, it's like a quite difficult for me to answer the question. If you ask me, like, if I talk about myself, definitely I would prefer to work on the medical images because I have started earlier. If you ask my suggestion, I would suggest something related to either marketing or to auto pathing, because I can see marketing is everything. Everything that we do, we need marketing. So marketing is a very promising field to use AI in that field. And at the same time, I can see there's a very huge demand now on auto pathing and lane detection, and it's like something is not that hard to do. Something is like something easy to implement. You can use a library called OpenCV to build a simulation, and based on that simulation, you can build a model based on the reinforcement learning.
Okay. Last two question, I guess. Then we'll end our session at 1:15. Right. So from here, the latest questions. Data scientists seems to be handling data from various fields. Do I'm sorry. Do data scientists need to have the knowledge from all the different fields?
Okay. So this is one thing about data scientists. You cannot be data scientist in every field. You have to choose the field that you want to be data scientist in. Like, for example, I talk about myself. I started with the medical images. So now I was offered, like, I think in 2019, I was offered like a basic salary with a 30K to work with the Petronas to use deep learning images. Sorry, to use deep learning technologies to work on the images that related to, they call it something geology, something like that. So even I was working on the medical images, then I found it quite difficult for me now to understand the images and to start use deep learning. So I just rejected the job because it's quite difficult to make that change, and I'm going to waste a lot of time to understand the data sets and the issues of those data sets and the tools that I need to use. So this is one thing also normally I share it during my training courses. It's like, you have to be data scientist in your field, or you have to choose a field to be data scientist in. You cannot be data scientist in every field.
So a data scientist do require some fundamental knowledge from the field that he'll be in charge in, right?
Yeah, definitely. Yes.
Okay.
In a specific field,
Hmm.
which is the field that they are going to be data scientists in.
I see. All right. So I think one last questions. I think is related to our university students. So how can I get into AI or maybe data scientist if I'm from a different field, maybe business or even engineering field?
All right, very good question. Just now we mentioned that every industry, every field, they need data scientists. And when it comes to business, it's like I think they are the place which they really in need to data scientists. And again, I would say this one more time. By the year of 2026, we are going to have we are going to have enough. We are going to have 11.5 million job opportunity to work as data scientists or to work in the field of big data for all kind of fields and industries, manufacturers, education, whatever. So definitely you are going to dive into to be data scientists in your field as a business students. Then again you need to find the field. Okay, you are into business, then you are going to work with the company and what this company doing, or what kind of data normally this company generating. So based on that data you can be data scientists in that data. If the company that maybe they are doing some like export and import. So you can build for them predictive model based on the data to solve the issues, to solve their return, to solve their improving their profit and so on. And whatever problem they have, work on their data. If you are going to work on the data doing a business like selling specific products, then you can work on that data. If they do a business like some service provider, then you are work on this data. So it depends. I think for business students, they have like better base and more wide base to be data scientists in that field, but they have to choose the field to be data scientists in, which is what kind of data to work on.
Mm-hmm. Maybe I'd like to add more a bit on these questions. So maybe like me, I'm actually engineering students that I feel like I wanna contribute myself in this data science. So would
Mhm.
doctor recommend me to have a self-learning, or is it will be better to have a proper learning? Maybe I'll have a second degree or I'll pursuing master for the data science. Is self-learning enough for me to join this field for career?
Okay, all right. So it's a very good question. So let's say I'm a recruiter. I'm recruiting data scientists. All right. If you ask me, I'm as a recruiter and I'm into this field. So I will do two things. I have the theory exam for the candidate, and I have the coding exam for the candidate. So once they perform well in those two exams, then they are going to get the job. And one more thing, I will look at their portfolio. So what makes me contact them to ask them for the interview or for those two exams? Their portfolio. The portfolio is very important. The portfolio, it is the way to show your knowledge. So once you show your knowledge, so people will contact you to work as data scientists. For the last, I would say, till like maybe 2021, till last year, data scientist job or data science is considered as, they call it what? They call it the most sexy job for the 21st century. Why? Because you don't have to have any discipline study to work as a data scientist. While data scientists, they're earning the highest salary and their job on highest demand. All right. So you don't have to be graduated as a from the faculty of data science to get that job. But recently, a lot of universities, they are offering this study as a disciplinary study in their universities. So, and companies, they are still not really aware of this field. So what do they do now? They want, I think, and even in the future, they want people who are graduated from the faculty of data science to be hired in their company. So for now, I think you can do self-learning and you can get a job in this field. But in the future, maybe it will be a requirement. Some of the companies, they will require people who are graduated from the Faculty of Data Science. Then they can hire them as data scientists.
So there are still chances for us to contribute now before it's grow that big that requires a basic
Absolutely.
accreditations.
Yes, absolutely, definitely.
Yeah, I think that's a good news for audience. All right, so I think with that questions will mark a full stop for our Q&A sessions. Do Doctor have any last advice or recommendation would give to our audience?
All right. My last advice, I think if you are going to be in this field, then you are on the right path for your future. This field is now on high demand, and this field is going to be even higher in the future. So it's worth to invest time in this future. It's worth to start learning in this future in this field. And then it is not difficult at all. It is only the matter of practice. You just need to practice. And you are always welcome to contact me. You are always welcome to my courses. I always share also my activities on LinkedIn. Please try to come and connect. And if you have any question, you can always drop me a message or drop me an email. I would love to look at those messages and emails. And should we share the files here in the chat, or later on you are going to send them an email?
I think we'll follow up them with an email regarding all the slides and the links for the course.
All right.
Yeah, I think that works.
So thanks to the wonderful audience, then you are going to get the slides and the files soon by email.
Yeah. So, all right. Thank you to Dr. Obey for the time today and the great sharing just now. We really appreciate Doctor's advice and wish you a great day ahead.
Thank you. Thank you so much. Thanks for having me. I'm really proud of you all to see the youth are interested in this field. And I wish you the best. Would love to collaborate with you. Always. Good luck.
All right. Thank you, Doctor.
Thank you. Bye-bye.
Bye-bye. All right. So before we end our workshop, we would like to ask for your favor to help to fill in our feedback forms to help in improving our programs to make our programs better in the next coming years. The links will also be given in the comments, so you may also approach to the feedback form there. And then there's a giveaway from MSTW22 for our audience. So the prize is worth up to 1,250 ringgit. So do fill in the form to increase your chance of winning these giveaway prizes. And last but not least, we would like to introduce the fundraiser for TFM. For MSTW this year, we have collaborated with Tech for Malaysia to have fundraiser for the underprivileged students in Malaysia. We'll provide them with necessaries and maybe accessories for them to continue their studies. And every 50 ringgit raised, 2 students will be positively impacted for a month. So we do hope you all are interested in it and will really appreciate your donation for it. And that's all for our workshops today. Here's a little reminder for our event this afternoon. It will be at 2 p.m. It's a panel discussions for artificial intelligence, which we have 4 panelists to discuss about the current situations of AI in Malaysia and also futures expand of this field. Do join this panel discussion if you would like to know more about artificial intelligence. And that marks an end to the workshop and the session of this morning, but if afternoon, I guess. So do stay tuned to our afternoon program and see you later. Thank you.